Thank you, everyone. Good morning to everyone for joining in. This is the day one for SDA design and deployment training. I just wanted to give you a brief insight about the training, right? We are not going to discuss the basic concepts of SDA over here. We understand that, or this is kind of like a prerequisite out over here. We believe that you're already versed with SDA as to how Lisp works, how VXLAN works. The primary agenda of this training is to let you partners know as to what are the new features in 2.x, and what is in store for you in the SDA release, right? That you can be looking forward to, so that when you go to your customers, you know that these features are out there, and it can help you to bring out business value to the customer and to your projects. My name is Abhishek. I am one of the SWAT engineers. My team primarily deals with software-defined access and software-defined WAN. We work with close proximity with the business unit, and we have designed this training in 3 days, where we will primarily talk about software-defined access updates. We'll talk about some of the new features that has been introduced, features related to SDA, related to non-SDA, right? And we would also be touching upon some of the new tools that the business unit has introduced for partners to help them troubleshoot their SD access solution and to troubleshoot their DNS center. I understand there can be a little language barrier if in case at any point you feel something is not clear. Please feel free to stop us. We have a lot of Cisco folks from your region as well. So if in case there is something which I'm not able to make it clear, I believe Hong, Ray, they're there to help us to sort those issues out. So please feel free, try to make it as much interactive as you can. For any questions you have, we are there for the next 3 to 4 days. So, and I have my colleague as well. So Narendra, if you want to introduce yourself.
This is Narendra, and I'm part of SWAT team. So both Abhishek and I will be presenting today's session, and we'll have another one of our colleague help us throughout the lab for next few days. So as Abhishek mentioned, this training is in a bit advanced training. So hopefully you guys have had some exposure to SDA and DNS Center so far, and from today onwards, we would be discussing what are the new updates and new integrations available with DNS Center, what are the new features. And those new features, most of those are part of the lab, some of those are not. We'll let you know which one are not part of the lab. And, you can experience those in the upcoming trainings, which would be the revised version of this training in future. So we will let you know whenever we release those new features in the lab also, okay? So as Abhishek mentioned, please make sure you ask questions. You have option to ask questions through Q&A panel. You have a Q&A panel on this WebEx. If you look, you should find it. And if you have any questions you want to ask verbally, please feel free to unmute yourself and ask those questions. We are also recording this session, so in case you want to download the recording later on, the local Cisco team will share the recording links with you guys. All right. Thank you. Abhishek, you're good to go.
Yep. Thanks, Narendra. So, all right. So the first session of the day, right, we're going to talk about the new software-defined access updates, which you will see in 2.1.1 and 2.1.2, right? So this is going to be the agenda for the session, right, where we are going to talk about primarily 4 features that has been introduced. One is the policy extended node, the other one being the multi-site border, third one, the stack-wise virtual link, and the fourth one, CLI preview. So if in case you guys might have worked with software-defined access, you might have already worked with pen nodes or the stack-wise virtual, right? So what is happening in 2.x is we are just expanding the capabilities to lot more devices, right? Which we're going to discuss in detail. And for if in case you have not worked on these two features, we would any case be showcasing and displaying how this works, even from the packet flow perspective. All right, so talking about the first use case, which is policy extended node, right? So before I jump on to the slides, right, I just wanted to call about for the people who are working with this for the first time, right? What exactly is an extended node? So as you might be knowing, inside an SD access environment, there is fabric edge, right? And from the fabric edge, you connect, or there is an option to connect another switch which is known as extended node. This extended node primarily works like an L2 switch, okay? And from the edge out to the control plane, right, it's all L3. So why do you need an extended node? Because if you have been working with software defined access, the philosophy is all L3, right? We always say go with L3, go with routed access. It gives you much more feature sets. It gives you a stable underlay, right? But there are scenarios where you might need to use an extended node, and one of the most prime scenarios would be your IoT devices. So with the introduction of IoT devices, some of the IoT devices can be silent hosts, right? And they might be over relying on your L2 technologies, and they might not work efficiently if you have an L3 routed access. So therefore, you might need to connect an extended node at the back of an edge node, right? And this link out that I'm highlighting, it needs to be a port channel. All this configuration that we are seeing, right, creation of a port channel, this is done automatically by your DNS center. You don't have to do anything manually in order to get your extended node inside your fabric, right? But then this extended node concept was being shipped from the release 1.2.x onwards, right? And as you know, inside the enterprise network, there is a lots and lots of push for your IoT. So you would be having an IoT sitting at the back of your extended node. So this is kind of like your IoT device, right? And let's say this is IoT 1, and you had another device sitting at the back of an extended node, which was IoT 2. So what did we give you in the release 1.2.x? We gave you the ability to have an L2 kind of a network in order to get your IoT devices onboarded without any issues. But then what is the prime, if you look about the prime use case of a software defined access, the prime use case of a software defined access is end-to-end segmentation, right? And we achieve end-to-end segmentation with the help of SGTs, right? So there was a problem with this particular setup, right? Where it used to work properly, right? No issues with the working of an extended node and your IoTs, but the problem was with the end-to-end segmentation. What do I mean by that is, right? As you might know, you go ahead and assign an STT to an endpoint, right? So for example, if this is IoT2, probably this IoT2 is nothing but the SGT of the device, right? And how do you define an SGT in an ST access network? Primarily, you do it with the help of ICE, or where you dynamically go to ICE, and ICE on the basis of your auth policies will go ahead and provide you with an SGT. But the problem with an extended node was that it was never .1x capable. So this extended nodes, they didn't have the functionality of .1x. So what did that mean? Since they were not capable of doing .1x, you could not even do trustsec on extended nodes, right? And as you know, .1x and trustsec are the basic pillar in SDA to give you end-to-end segmentation. But inside the extended nodes, you could not do .1x, you could not do trustsec. So how did you enforce policy in 1.2.x? For IoT devices, or for, I would say, any device that was connected to an extended node, we used to rely on our fabric edge to do the enforcement, or to do the SDACL enforcement from or basically inside our SD access network. So the problem with that was, since we were doing the enforcement at the fabric edge, only north to south traffic or south to north traffic was getting catered to by the policy. The reason for that is, right, in order for fabric edge to apply a policy, the traffic had to go from an extended node out over here, right, go to the fabric edge, right, and from the fabric edge, if in case it was going to the control plane, right, it could have gone out to the control plane, and when it was coming back, it could have enforced the policy out on the edge, right? Similarly, if in case the traffic was going to a different edge altogether, the traffic would have gone to the edge, and on the other edge, the policy would have been enforced. But if you look in this same example, if in case IoT 1 and IoT 2, let's say IoT 1 was kind of like a light bulb, right? And IoT 2 was kind of like a different IoT, let's say medical machine, right? And as you can see now, a medical machine might have a more priority, right? This might be more business critical for you rather than like a light bulb. And generally light bulb might be publicly available. So you also wanted to have east to west segmentation, which basically means that there might be scenarios where you want IoT 1 not to talk to IoT 2, right? This east west. So north south transfer of communication or north south enforcement was being done by the fabric edge even in 1.2, but east west communication, which basically means IoT 1 to IoT 2, for which it did not have to traverse through the fabric edge, that enforcement did not happen in 1.2.x. And that was a prime, you can say a prime feedback from the field, where because of the increase in the IoT devices, it was required to even give us or give the partners and a customer a way to do your east to west segmentation, which is basically saying, if in case you wanted to create a policy or if you want to restrict communication between IoT 1 and IoT 2, you needed a TrustSec configuration even on an extended node. So that's what a policy extended node does. So an extended node, in very basic layman words, it doesn't enforce policies. It is not .1x and TrustSec capable. A policy extended node is .1x and TrustSec capable. Okay. So right now we only spoke about the extended node and the journey of the extended node, right? So what happened was, in the last release to 2.1.x, right, there was a release which you might have worked on, which was 1.3.3.3, right? This was the first time the concept of policy extended node was released, right? But at that time, it was only limited to a certain hardware. So let's see what it was restricted to. So in 1.3.3.3, it was only restricted to these two hardware models, which was IE3400 and IE3400H. Okay. So if in case you're running 1.3.3, you can still use the concept of a policy extended node, which basically is nothing but an extended node that has the functionality of .1x and TrustSec on that box. Okay. But if in case you are using 1.3.3.3, this particular functionality can only be found on these two hardware boxes. All right. I think there might be a question. Okay. I think not. All right. So guys, if in case you don't have a question, I would kindly request you guys to mute yourself.
我嗰個 Ethan 係咪喺度啊？
Hong or Ray, can you help us with that? Probably either there was a question or.
I think it should be fine. Yeah, I think it should be fine. Yeah.
Oh, okay.
You can go ahead.
All right, great.
Yeah.
All right. So yeah, so then how did the .1x worked, right? As we discussed, it used to work the same way as it works in a fabric, where you rely on Cisco ICE to go ahead and provide you the VLAN and SGT dynamically on an extended node. So it worked the same way as the assignment worked on a fabric edge, right? And the configuration of .1x and TrustSec is all automated by the DNS center. So the way you don't have to do anything manual on your fabric edge or border control plane node. Similarly, you don't have to do anything manually on your extended node. Okay. The only configuration that you need to look into over here is, and I've only highlighted it before, but I will just call it again, right? When you go ahead and attach an extended node to a fabric edge, right? The link between the two, it becomes a port channel. And the only protocol that it supports to do a port channel is PAGP. Okay. This again is automated. The only thing you might need to do is on the fabric edge, you would need to create a port channel via the DNS center beforehand. So once you create a port channel out over here, on the extended node, you have to do nothing in order to onboard your extended node. Okay. So up till here, everything, if you might have worked on 1.3, it was the same, right? We gave you functionality of a policy extended node for these two hardwares. So what is different in the newer release? In the newer release, we have expanded this functionality out to your Cat 9K boxes, which basically includes your 9200, your 9200Ls, your 9300, your 9300Ls, your 9400s, your 9500s, and your 9500H. Okay. So now you can have even a Cat 9K box work as an extended node. Okay. And the only limitation being that if in case you're thinking of placing a Cat 9600 at the back of an FE, it's not going to work. Okay. Additionally, you can even do stacking of an extended node, right? Like for a 9300, you can use the stackwise cable, right? But the only catch over here is if in case you're using a 9500, right, then you might need to do an SVL, and SVL on an extended node is not supported, right? So only at this point of time with 2.x, only a physical stack of switches are supported as an extended node, but a stackwise virtual switches are not supported. So very important point to take into notice, right? So coming to the last point, right? I think I will explain this in the next slide as to how does SDT inline works. All right. So here we are going to talk about, like, this is kind of like a pictorial form of how an extended node or a policy, I must say a policy extended node and a fabric edge looks like. So if you guys have a look where it says extended node, this is what your legacy extended node looks like, which still functions, right? So in order to have an extended node only functionality where you do not want to enforce policies, these are the hardwares that support it. So any hardware that is listed out over here, these hardwares are also supported as extended nodes. The only thing is they will not do enforcements, or in other words, they are not .1x or TrustSec capable. On the right, which I just highlighted, these are the new hardware that is supported for policy extended node in 2.1.x. Okay. Looking at the configuration standpoint, right, as you see this particular circle, it actually signifies a port channel, which we already have understood, right? So, and you can see what ICE is doing out over here, right? ICE is giving you a dynamic assignment, right? So if you see on the right hand side, which signifies with a yellow line, right, the ICE for the policy extended node is capable of dynamically providing a VLAN and an SGT. So it's the same way, right, the way your fabric edge works with an ICE. Even for an endpoint that is connected at the back of a fabric edge, ICE would be providing the fabric edge with a VLAN and an SGT. So it's doing the same thing for an extended node as well. Now, the other question that can be, right, for example, let's say over here you have a edge or you have a client which is with the SGT called IoT, right? How to carry this source tag to this fabric, right? So because if you look from a fabric edge perspective, if you have a client 1 C1, if you have a client 2 C2, or you can say with the tag C1 and with the tag C2, if C1 wants to talk to C2, the enforcement will happen at the destination fabric edge, which is over here, right? And the source tag, which is of C1, it would be carried inside a VXLAN header, right? I hope everyone knows about it, right? Because this is classic flow of a traffic inside a SD access fabric, right? So in order to do enforcement, the source tag is carried within VXLAN, and that is for your classic fabric. What happens inside the fabric if in case you have a policy extended node connected, right? So again, if you see the ethos of enforcement, right, the enforcement will again happen at the destination fabric edge, right? But in order to have that, you have to propagate your source tag, right? So let me just go ahead and clear this out and try to create a example use case so that everyone can understand this. All right, so I'm just trying to explain how east to west communication will happen right now, okay? Which in the earlier extended node, it was not possible. So let us just assume that this guy over here is also a pen node, a policy extended node, and you have another device connected out over here, which is IoT 2, okay? This guy has an SDT tag of IoT, this guy has an SDT tag of IoT 2, right? So it got the SDT tag from Cisco ICE. So now, in order to do the enforcement, right, what is the first thing that it needs to do? It needs to find a way to transfer that SGT from an extended node out to the fabric edge, right? The way the extended node transfers this tag of IoT from an extended node out to the fabric edge, it is done by the mechanism known as inline tags. This again is not a new feature. If anyone has been working with TrustSec, they would be aware or they would know how inline tag works. Inline tag basically works at the layer 2. It doesn't uses any new header. It basically uses the frame, and inside the frame it uses the 8-bit header of Cisco metadata, which is used to carry the SGT value from the source till the destination. So you would see whenever you create a policy extended node, you will automatically configure even the configuration of inline tags everywhere. So basically two configuration gets created. One, a port channel by default, even if in case you have a single uplink between your extended node and a fabric edge, even then a port channel will get configured. And additionally, the inline tags get configured on the interface at the fabric edge, which connects to the extended node, and vice versa on the extended node, right? What will be the packet flow we are going to talk about, but then we need to understand what is the mechanism to carry SGTs from your extended node out to your fabric edge. So if you have a look into the packet flow, right? So as you might have seen over here, we have this host 1 connected to an extended node, and there is host 2 connected to the other extended node, right? So host 1 has an SGT of 100. So the basic thumb rule of enforcement is enforcement happens at the destination switch, right? So since now extended node is TrustSec capable, so the enforcement will always happen at the destination switch, which is over here, a policy extended node. So what will happen is when this traffic or this host generates a traffic, the traffic will reach the extended node. From the extended node out to the fabric edge, right? The SGT will be carried with the help of inline mechanism, which is basically the tag would be put inside the L2 frame or in normal L2 frame that is there inside your packet. So this way the SGT is restored between an extended node and a fabric edge. Between fabric edge to a fabric edge, the SGT would be carried inside VXLAN. That's what is written over here because this is classic fabric, right? Once the traffic reaches on the destination fabric edge, right, since the destination is not connected to the fabric edge, it's connected to the extended node, it will send that traffic back or it will send the traffic out to the extended node. So now again the SGT that was carried in the VXLAN, it will again be carried by the mechanism of inline tags out to the extended node. And now on the basis of your TrustSec policy, that you might have created on your DNS center or ICE, either the packet would be allowed or the packet would be disallowed. Okay. So this is again the same flow, right? But if in case this is showcasing what happens when a host is directly connected to a fabric edge, but not to an extended node, right? So the traffic flow will be the same. Whenever a host one generates a traffic, the traffic reaches an extended node. The extended node will send the SGT out to the fabric edge via inline mechanism. From the fabric edge out to the other fabric edge, or the destination fabric edge, it will be carried inside VXLAN. And now since the destination is directly connected, the enforcement will happen at the fabric edge itself. So nothing very different from what you have been doing or you might have been used to towards SD access. The last flow that I'm going to talk about, right? What if host 1 and host 2 are connected to the same extended node? So this again works the same way as it works for the fabric edge. So when the traffic reaches out to the extended node, right, the extended node will have the policy downloaded for a traffic from a host 1 to host 2. If in case there is a block, the traffic will be blocked right then and there. So as you see now, you have a full segmentation from the north-south traffic and for your east-west traffic with policy extended nodes. So therefore, now you're achieving the correct, or you're actually achieving the end-to-end segmentation, even with your extended nodes or even for any device that is connected to an extended node. There are just certain things that we wanted to call out, right? Because this is a new feature, right? Ensure that this feature is not supported for a 9600, right? And if in case you're doing 9600 and you're thinking of using it as a policy extended node, it's not going to work. With software-defined access, along with the hardware models, the software versions also matter a lot, right? So if in case you are running a Cat 9K, and this version only applies for Cat 9K. So if in case you're running or you're planning to use a Cat 9K as a policy extended node, make sure you're using this particular version or any version above this. Okay. A policy extended node cannot be multi-homed, which basically what does it mean? That if in case you have a fabric edge out over here, right, you can only connect an extended node to one fabric edge, right? People generally what they can think is, if in case there is fabric edge 1, there is fabric edge 2, they can like create kind of this setup, right? If you do this, this becomes not supported. You cannot have a second uplink from an extended node out to a different fabric edge. It is only restricted to one extended node. So a fabric edge can only have an extended node directly connected to one fabric edge. You cannot have like two uplinks going towards other fabric edge. If you do that, it's not supported. Okay. We have already covered about that stack-wise virtual is not supported with extended nodes, so just make sure of that, right? And additionally, if you think about of doing a daisy chain, which basically means that connecting extended node at the back of another extended node, right? This again will not be supported. So if you have a extended node out over here and you connect another extended node at the back, this again will not be supported, right? So very important thing to note over here. As I said, right, the extended node workflow is automated from DNS Center, right? So you don't have to do anything specific in order to get your, or in order to start that automation process, right? The only thing that you need to do is you need to provide the DHCP server, or basically I would say inside your DHCP server, you have to provide a DHCP scope for your extended node so that your extended nodes can get an IP, right, from that DHCP server. And you also need to ensure that you're applying or you're giving an option 43 over there. The option 43 will nothing be, but it will be an IP of your DNS center, right? So what happens is, right, as you know, or what I've been telling you is the onboarding of a policy extended node is automated, right? Yes, it is automated, right? But then there is just one thing that you need to take a note of. If in case you are doing a LAN automation, right, which basically means that you have manually started a LAN automation process, whenever a LAN automation process is under processing or it's going on, your extended nodes will not get onboarded. Or what I mean by that is automatic configuration on your extended node will not work. So at one time, you can either have LAN automation process running or you can have a policy extended node automation running. The policy extended node automation runs by default, right? It's just that whenever you enable as an admin a LAN automation process, it automatically gets disabled at the back end. Once you stop the LAN automation process, the policy extended node automation process initiates on its own at the back end, right? So if you see that your extended nodes are not getting onboarded, right, inside your fabric, just ensure that you do not have a LAN automation process running inside your DNSE. So guys, that was what we had from the policy extended node perspective. I will just break for like 1 or 2 minutes. I'll not break, basically I will just open it up. If in case you have any questions regarding policy extended nodes, please let me know. Okay, I think no questions, and nor do I see any questions in the chat or the Q&A panel. Right. So the next feature that we wanted to talk about, right, is multi-site remote border. Okay. This is a new feature that would be introduced in 2.1.x, or is introduced because now 2.1.x is general availability, right? So what exactly is a remote site border? And I think this slide explains it in a best way, right? So before we do this, right, I think the first question would come out is, why did we come up with this particular solution, right? Or what was the need for a particular new feature, right? So if in case you have worked with multi-site or SDA multi-site, right, you might have known there is, I would not say a limitation, but a restriction. So what does that restriction is? If you're doing a multi-site, if in case you have a site 1, you have site 2, and you have a site 3, right? So if you're doing a multi-site, you cannot have same subnets across all sites. What do I mean by that is, for example, let's say your customer wants 1.1.1.x subnet over here. Similarly, he wants a 1.1.x subnet over here. Similarly, he wants a 1.1.x subnet over here. Let's make it /24, right? And 1.1.x subnet over here. So basically there can be, or there are scenarios from the field where customer wants to have the same subnet across all the sites, right? And the prime use case where you will see this coming would be the guest or your guest network. So we got a lot and lots of requests out from the field where when customer were, or whenever there was design discussions, most of the customers wanted to use the same subnet across all the sites specifically for their guest network, right? And this was a restriction from a SDA multi-site perspective, which basically meant that if you're making an multi-site, or for that matter, if you're making multiple sites, not even connecting via SDA transit, connecting it via IP transit, you cannot have same subnets across multiple sites, right? So this way, the ask of the customer was not being catered to. So therefore, what did we bring up? We brought a new feature inside 2.x, which is known as multi-site remote border, that allows the partner and the customer to configure same subnet across different sites. How is that done? Let's talk about it. All right, so the feature overview talks about the same thing that we just spoke about right now, right? So in this particular use case, right, or in this particular scenario, you can see there are 3 sites, right? One is DMZ, site 2, and site 3, right? So every site has their own border and control plane, which is defined out over here, right? So how is it different, right? If you have a look into the Fabric site 2, you let's not have a look at Fabric site 2, we have a look at Fabric site 3, right? So if you look at the employee out over here, the employee's border node and control plane is local to this site, right? So therefore, for any queries that the switch has for respect to the employee virtual network, and over here we are not talking from a endpoint perspective, we are talking from a virtual network perspective, right? So whenever or any client that connects to this particular employee virtual network, the border and the control plane would be the ones that are local to the site, right? If you have a look into this yellow virtual network, which is for your guest, right? This is the difference where we call out the multi-site remote border, where whenever a client connects to this particular virtual network, which is the guest, the border and the control plane for this particular VN is not going to be the local border and control plane. It's going to be the multi-site remote border that you have defined as an admin. Since it's a guest, we are placing it in the DMZ. So probably you have another firewall, your inside firewall, you have your outside firewall, and this box is sitting in between the two inside the DMZ. So how does that help is, it helps because now if you have a look at the Fabric site 2, even there you have this yellow virtual network, which is guest, right? But then even the border control plane for the guest VN is located at the border control plane inside your DMZ, which over here is working like a multi-site border. So if you have a look from, or if you understand from an holistic point, right, the guest, for only for the guest network, you have a border and control plane, which is kind of like a different box altogether in a different site altogether, only for the guest virtual network, right? And for your employee virtual network, the border and control plane is local, right? For your anchored IoT or your IoT virtual network, for Fabric site 2 over here, it's actually the local border and control plane. But on the other side, even the border and control plane of an IoT is on a different site altogether, which is site 2. So we give you the luxury of having a common border and control plane across sites, right? But then you will generally use this particular scenario when you want to have the same IP addresses across site, and the prime use case for this is guest, right? And you will generally see this being worked upon when you are using it for guest network, where you can go ahead and you can say bind your guest control and border traffic to an isolated border and control plane. This gives you additional level of security as well, because now your because now your guest prefixes are isolated, and as well as your data plane for guest is also isolated in order to go outside the network. All right. So how to understand these concepts, right? So the multi-site border, or the site where it, you can say the site where you have the border and control plane that is going to cater to the needs of the virtual networks and other sites, we call it as an anchored VN. Okay, so on this site, this fabric site 1, where you have this border and control plane which is going to cater to the virtual networks and fabric site 1 and a fabric site 3, this is known as what? This is now going to be known as an anchored VN on this particular box. Okay, so this configuration, right, of an anchored VN, it needs to be done first. So you cannot go ahead and configure guest network on fabric site 2 and fabric site 3 if you want to go ahead and use the multi-site border or the anchored VN on this site 1. First, you will have to do the binding on the site 1, and then only you can do it on site 2 and site 3, right? And again, so this guest, when you go under host onboarding, right, that is where you assign a virtual network out to a site, right? And when you do that, that will be known as an anchored VN. And the site where you do this, so this site will be known as an anchor site. So it's kind of like saying the virtual network when you have assigned to the site 1 is now not only a virtual network, but it is also an anchored virtual network, right? And the site where you have done this, in this case fabric site 1, that is known as an anchor site, right? So what is the third point saying, right, where it says, right, where you have this anchored VN, as we said, right? Now this anchored VN will be present across multiple sites, right? The reason for that is every VN that is present on any other site, right, which is over here, site 2 and site 3, for them, the border and control plane would be the border and control plane inside this site, right? I will not talk about from the configuration perspective, right? But because the configuration is all automated by the DNSE, you don't have to worry about the configuration. But you do need to understand the logic behind it, right? So basically what we are doing is we are basically sending the traffic of the guest from site 2 and site 3 out to the centralized border and a control plane, right? Now, if you talk from the wireless perspective, even the wireless is supported in this design, but the only catch over here is, since now you're going to have a wireless controller per site, right? So this wireless controller also needs to talk to this multi-site control plane, and it also needs to talk to its local control plane, right? So what does that mean? You cannot, or I would say in a production environment, you cannot use an AirOS for this particular feature set. AirOS will not work for this particular feature set because the AirOS has a limitation that it can only support 2 control planes, right? And as you see, the 2 control planes will obviously be there because one, it will be the anchored site border control plane, and one would be the local control plane. But then obviously, if you're thinking from a production environment, you would like to have 2 boxes out over here, and you will have like to have a 2 boxes in your local site as well. So what does that make? That makes AirOS kind of like incompatible for the solution, If you're talking from a production environment, can you do it in your lab? Obviously, you can use AirOS in your lab, right? But if you're thinking from a production environment, this might not work out. So what to do with a WLC controller perspective, right? You can use a 9800 controller. You can use a 9800 CL or either hardware appliance, right? Anything works. So because 9800 can support up to 16 control planes. So therefore, it gives you a lot more leverage and power of using a 9800 for this use case. And if you look from in all fairness, because of the limitation of AirOS, if you plan to go with this particular design, you would have to use a 9800. All right, before I go into considerations, any questions on this or on the flow, right, which you would like me to clear? Okay. All right. So as we discussed, right, there are two sites, right? One is the anchor site. So this guy out over here is your anchored site, and this guy out over here is your anchoring site, right? So over here as well, this is your anchoring site. So if you see, what we are doing is, we are basically doing is for a virtual network of guests, we are extending the fabric from the local site out to a different site, right? So again, all the limitations that we have spoke about when you're creating a fabric from an underlay perspective needs to be there. You have to enable 9100 MTU between your edges over here on site 2 or site 3 and your border control plane, which would be sitting inside your DMZ. You need to enable 9100 MTU across the board, right? That is very important. Because if you don't do that, right, your packet might get dropped and you would not get the necessary quality of, like, your solution will not work as expected, right? Other thing that you will need to do out over here is now, because if you look from this particular anchor site perspective, right, even the edges over here in this site are a fabric edge for this border control plane. Even the fabric edges out over here are like a fabric edge for this border control plane, right? So this gives you the ability to talk, or the guest can talk between one site to another site, right? So if in case you want to do policies, if you want to enforce policies of avoiding this, you would need to probably just make like a guest to guest block, right? You can do that, right? But then this can be a very useful scenario if in case you're talking from an IoT perspective, where you want to have a communication between IoT in one site and IoT another site, because they are practically the same, you can say practically the same group of devices. But then what you have to ensure is, you have to ensure that you have a /32 route for the loop back of the fabric edges and the border control plane inside the rib of every fabric edge. So basically what I'm saying is, a /32 route in order to reach to the fabric edge on this site, if in case you want to have a communication across sites, right? Similarly, you also need to have a /32 in order to reach to the border control plane. Why? Because when you send the default traffic out from the fabric edge to the border, right, it will go from this fabric edge to the multi-site um, border node, right? So you need to ensure that you have the loopback addresses as /32 prefixes, right, inside the rib entry. After that, we have already discussed about these 2 points, so I'm not going to touch upon them, right? So when you're creating the anchored or you're creating your anchor site, right, we are not restricting you to having a co-located design, right? You can have a distributed design as well, where you can have a control plane on one, you can have a border node on one, right? So it's totally up to you. You can have a co-located, you can have a distributed design. No one is stopping you from doing that, right? So again, these limitations, if we speak about, right, these limitations are the same. Um, even if in case you talk from a single site perspective, right, you always have to look into the scale limits, right, as to what are the number of pools, virtual networks, and SDACLs that would be supported by a fabric edge. That doesn't change at all, because if you look at it, it's just that you're creating a fabric site. So you only have to look from a fabric site perspective. This limitation of the number of borders has been the same, right? You can have maximum of 4 borders or 4 external borders per site. So whenever you're creating a fabric site, be it anchoring sites or your anchor sites, make sure you're not having more than 4 external borders. All right. One important thing, if you think this can lead to misconceptions, right? Since now we are saying that you have a multi-site border, right? And then uh, you're basically dumping all the prefixes from both the sides out to this common control plane. So the seamless roaming might work. Seamless roaming is not supported as of now, right? So make sure that you not might, but you will face issues, not issues, but you will not face, you will not have a seamless roaming experience when we go from one fabric site to another. So that is totally expected. There are sometimes confusions, right? If you look from this particular topology of the multi-site border, people might confuse it to software-defined access transit or SDA transit. So SDA transit and multi-site border are totally two different things altogether. They have nothing to do with each other. You can configure SDA transit and you can also do a multi-site border. You can not do an SDA transit and you can still do a multi-site border. That's totally there. Nothing to do with your SDA transit and multi-site border. Okay. If you have IoT devices, right, and this is specifically for your IoT cases, if in case you have IoT across different sites and you want to go ahead and like make them talk across sites, but then a multicast is a very important use case, or the way they work between, or the way they talk to each other is by using multicast, then this solution might not work out for you. Then you will have to use local border control plane nodes, because multi-site across different sites is not supported as of now. Okay. You can, and this makes sense, right? This other point that we're talking about, right? If in case you see there was a fabric site 1 that we had made as an anchor site. So for one virtual network, you can only have one anchored site, right? Probably for a different virtual network, you can make it like a different site. But when you're talking from one virtual network, you can just have it on one site, right? There is a difference in the workflow of the guest. So if in case you're thinking of using the guest flow as a multi-site border, not like a locally restricted guest network, if you remember, when you go under virtual network, you create your guest network, you have to check box an option saying that it's a guest network, right? But if in case you are going to deploy a guest network as a multi-site border, you do not have to check it. Make sure you're not checking it. Okay. If you check that, then your multi-site border flow will get affected. So ensure you're not doing it. Okay. Your anchored VN, right? Your anchored VN in this case is guest, right? It should first be binded, or binded how? Via the host onboarding page, right? Inside the anchor site, or the site which is going to have the multi-site border and control plane. No other site should have already deployed that virtual network. So the DNS center does a check, right? When you make an anchored VN, you have to do certain configurations to make it an anchored VN. I'm just going to show it to you. I have a slide deck for that as well. But you have to ensure that that particular virtual network is not present on any other fabric site. If it's present, it will give you a pop-up saying that you cannot make a virtual network as anchored VN, as the virtual network already exists across multiple sites. Okay. All right. Now the last part of the considerations, right? This is related to your guest border and an anchored VN, right? So what it says is, if in case you might have worked on 1.3 or 1.2, there was a concept of guest border and control, right? For all the people who have worked with this, right? We just wanted to tell you with the introduction of 2.x, right? That feature has been taken back. So if in case you have already deployed the border node and like guest border and a guest control plane in order to isolate your guest traffic, that will still continue to work in 2.x, right? But then any guys who are thinking that we are going to deploy a new guest border and control plane, that is not going to work. Okay. The reason for that is you will not even get an option to go ahead and configure a guest border and control plane, because now the multi-site border is going to play that role. So if in case you might have seen the slide and you might have worked with the guest border and control plane before, you can see the similarities, right? Where we are isolating your control and data plane, right? It's just that we are giving you additional functionality. So we have taken back the guest border and control plane node functionality. Now you will only have multi-site border. The only thing is, if in case you still like, if in case you had it like from 1.2 or 1.3 and you upgraded it to 2.x, you will continue to use it. That's not a problem, right? But then if in case you want to make any changes or anything, we will recommend that you go ahead and disable the guest border functionality and switch over to multi-site border coming 2.x onwards, because that's the only option you will get in 2.x. Okay. So that's what it's mentioned out over here, right? Whatever you spoke about, it's just mentioned in four individual points. All right. So if you now we're just going to talk about from the configuration perspective, how do you go ahead and do this configuration, right? So if you see this over here, it's a guest virtual network, and this is the way you are making it an anchored VN. Okay. Once you go under host onboarding, you click on the guest virtual network, you will see this option out over here. Use border control plane for the site to be common for the virtual network. So since when you do it for the first time, you will have to check this, you will hit save, and then you will be allowed to add an host pool to this, right? If you have already added a host pool and then you go ahead and check this, it will give you an error. So make sure first you check this, hit save, and then apply the address pool out over here. So additionally make sure that the guest VN is not added to any other site inside your domain. Once you do this, when you apply a IP pool, you will see this common pool getting enabled. You will see that the common pool is enabled, and on the page you will see this icon out over here, signifying that it's an anchored VN. And if you hover your mouse, it will tell you that the VN is anchored on this site. Similarly, once you do it for the other sites, right, you will see this anchored VN again, but then when you hover your mouse on that particular virtual network, it will give you where the common border is. For example, over here, the common border is at Sacramento site. So that's what the DNS center is letting the user know. All right, I will take a pause. If you have any questions, let me know.
如果有怕的有问题的话，也可以在这个 chatbot 里面提问啊。If you have any questions, you can type it in the chatbot. So for the trainers to know that.
Yes, yes, guys. So you can use the Q&A panel, and you can even use the chat box that are there inside the training, or WebEx, for any questions that you have regarding the delivery that we are doing out over here. All right. I think if there are no questions, we will move on to the other feature. This is the second last feature that we wanted to discuss on this slide. This is the Stackwise Virtual. So, all right. So if you have a look from the Stackwise Virtual, right, this is nothing new, right? If in case you have been working with 9500. So basically, we would say this is not a feature of SDA or a DNS center. This is a feature of a 9500s or 9500H right? Where if you want to connect two 9500 as a stack wise or as a stack switch, you will use a stack wise, like you will use a stack wise virtual links to do that, right? So it was not supported. It became supported in the DNS center from 1.3.3 onwards. The support in 1.3.3 only came for 9500s, right? So that was the thing, right? When it got introduced that the DNS center is going to support stack-wise virtual, it was only in 1.3.3 only for 9500s. The difference in 2.1.x is, sorry, the difference in 2.1.x is it has been the stack-wise virtual support has been expanded to primarily all the 9K family. So that's what we have mentioned out over here, right? Earlier, it was only done on 9500. With 2.x onwards, even a 9400 and a 9600 would be supported for your stack-wise virtual links. Again, you have to make sure about the software that you're running this particular software out over here, which is equal or greater than the software mentioned in the point 1. As in 1.3.3, right? Stack-wise virtual links between the two boxes are not automated by the DNS center, right? What you have to do is you have to manually make them a stack switch, like you have to manually make them as a stack switch with the SVL config manually on both the boxes. Once they have become peers with each other, then you need to add those devices out to the inventory. Okay. So what does that mean? That this SVL configuration that is there, it is not going to be it's not going to be automated by the DNS center. That's totally manual at this point, right? But what you can do is once you have done this manual configuration and made them a stack switch, right, then you can go ahead and discover them from the DNS center, and they would be treated like one box, or they would be treated like 19500 or 19400 or 19600. Okay. This point says that this links that you see out over here, which could be like your SVL links or dead or alive detection interfaces, uh, make sure you're not using them for host onboarding or for your L3 handoffs, which I think you will not, because these are your very important links. But just we wanted to call this out, right? That you will not be having or LAN automation nor border automation supported on your SVL or DAD links. Okay, but any other host facing links, you can totally do L3 automation, and you can totally do LAN automation. Okay. So when you're using this SVL links, right, or you're using this SVL switches, stack switches via SVL, LAN automation works on them, right? You can use LAN automation with them. The only thing is you can only make use of these devices as seed devices. Okay. The reason is pretty clear, right? As I said, that you cannot PNP it, or you cannot use it like a PNP agent switch, because DNS center cannot do the SVL configuration for you. So therefore, what the workflow for a LAN automated switch will be, you will manually create this SVL pairing between the two boxes. You will discover it manually out to the DNS center, and then you have the functionality of using these as seed devices. Okay. All right. Very important point, which we have highlighted in red out over here, right? So as you know, you can use a 9500 or a 9400 as a fabric edge as well, right? Though this would be on a less cases, right? But you might see 9400 more as a fabric edge use case, right? So what we want to call this out is, if in case you are using a 9400 or a 9500 or a 9600 as a SVL switch, right? Basically, you have created an SVL, you brought it to the DNS center, you got it to the inventory, right? And then you assigned an edge role to it, right? The wireless will not work on this, which basically means that your access points, your fabric access points will not work. It will not broadcast fabric SSIDs. So even though it gives you greater port density if you're using an SVL, but we want to call this out that you will not get an fabric AP support on an SVL switch. Okay, you can have like an individual switch, that's not a problem, but if in case you're talking from an SVL switch perspective, a fabric AP will not be supported. Okay. All right. So the other thing which you have already discussed about, right? You cannot have an SVL as a policy extended node as well. That's like a big no-no. So yeah, make sure you are not doing that. And additionally, you're not connecting any access point at the back of a 9400 or a 95 or a 96. If in case you are creating an SVL links or you're onboarding it as a SVL device. Okay. But if in case you are using non-fabric APs, which are basically running on the top wireless or OTT, those will still continue to function. It's the only problem is with the fabric APs which broadcast fabric SSIDs. Okay. So this only talks about what is supported and what is not supported. So I will not read through it. We will share the slide deck. You can go through this. Again, this sample talks about what is supported and what not. We have already talked about this, right? So where it says that if you're using an SVL fabric edge, your access points will not be supported, be it directly connected or even connected via an extended node. The fabric APs will not be supported, right? But if in case you're using like a normal fabric edge, right, which is not SVL, you can use access points, no problems at all. Again, if in case you're using a SVL link or an SVL switch, again, the fabric mode APs will not be supported. We can use legacy APs, that's not a problem, but fabric mode APs will not be supported. All right, so that was just like a very it's sort of like a short introduction out to the SVL. So now the last topic of this session is the CLI preview. This is a new feature that has been introduced in this particular release, right? Where we give you the functionality to see what are the configurations DNS Center is going to push out to the devices. Okay. So let's have a look into this, right? So what had happened was, if you have worked with DNS Center before, right? You make changes to the DNS Center, like which is total automation. You hit some knobs here and there. You hit save. You hit deploy. DNS Center pushes and lots of configuration at the back end, right? So there was a lots and lots of requests coming on from the field that they wanted like a CLI preview, which actually showcased what was being pushed out to their boxes, right? So this is what this feature talks about. Now you have the functionality to see what are the configuration of the commands that the DNS Center is going to push out. How do you do that, right? When you click on save and you hit on deploy, it comes to this option, right? Where it says now, later, or generate configuration preview, right? So generally in the older releases, you only had these two options. This option has come up new in 2.x, where if you click on this, and now it even gives you the functionality to name the task. Like for example, you're given this task, it will show you the configuration set that is being pushed or is going to be pushed by the DNS Center out to your switches, right? Over here, it is showing to what all switches the configuration would be pushed. And if you click on one of the switch as it is clicked out over here, it's going to show you the configuration that the DNS Center is going to push. Okay. So this is like a really handy thing, right? Even when you are doing lab, you can use this, right? And once you do this on the same page, it will give you an option to configure or not as well. So it's not like you have to do the workflow again. From the same place, you can go ahead and do the workflow. Okay. So you can see this over here under the work items, right? And now if you go under this option of 3 bars, you will see an option of activity. Once you click on activity, you will come to this page. The audit logs is also something new which has been added to this release, which basically shows you the user ID of the user who has made change out to the DNS center. Since it is a controller, we wanted to give an audit functionality, which was also a request for day and operations. So now you can just go ahead and go through this particular pieces of the web page and see how does this look like. This audit log just shows what configuration was done and who did the config. Tasks shows that any task that you have done on the DNS center, like from provisioning to discovery to provisioning of the fabric, every task will be listed out over here, as you can see, right? And it will tell you the status as well, whether it was a success or it was a failure. Work items, which you've already spoke about, which gives you a preview of the configuration. And then once you get the preview, you can just go ahead and hit deploy. And then the DNS center will go ahead and push all this configuration out to your switches. So guys, that was the feature sets that we wanted to talk about for the first session. Last call out, if in case you have any questions about the feature sets discussed, let us know. If not, we can head out for like a 15 minutes breather. All right.
Okay, thank you. Thank you very much. Because today we only have a live report for the lab sessions, so I know all the candidates around is on or 20 something others joining sessions. So we will arrange. I will try to arrange maybe 2 candidates using the same port, and then we will try to arrange 2 same company and candidate to use the same port on the lab sessions. So just in case, if you don't have time to using the lab, please let us know, and then we will not arrange the lab for you. So for the lab sessions, we will at the afternoon, as I remember, because this is 4-day sessions, and then first 2 days and 3 days is the morning time will be the tutorial, and then the afternoon time will be the lab time. The last day will be all days lab, but the trainer will be working to you together. And just in case if you have any questions, ask the trainer anytime. Yeah. So with any partners who joined later, please download the WebEx Teams where the chatbot, and then download the Cisco AnyConnect where the chat. So and then you can ask questions with WebEx Teams. Thank you. 请大家因为今天我们的拖的机甲没有那么多，所以我们尽量是2个人用1个机甲，但是这个机甲呢我们大概是尽量是2个人同一家公司去选用到的，所以没有问题的。我们晚一点的时候白涛伟帮我们去分配这个lab 的机甲，所以有问题的话，如果不能用的话，那就告诉我吧，那时候我就不会安排这个机甲的时间给你。好，谢谢你，谢谢大家。我们休息15分钟吧。Just take 15 minutes break. Oh, thank you. To log in your WebEx Teams, I have shared any connect zip file for the Windows. Please download it and install it. Please install the WebEx. Open the group. Cisco multi-domain training for GC, and then all the partners and trainers will be in the group, so you can ask the questions, and then you also can download the information. We will share it. Yeah, we'll share it.
Okay, guys. So hopefully everyone is back. We can start with the next part of the session. Is that okay? All right. All right, guys. I hope the recording is still going on. Okay. All right. So today Abhishek shared with us about the updates on the software-defined access. So we are now in the next part of the training where we would be talking about the analytics or endpoint analytics in DNA Center. This is another feature or update that came into the newer code, and I will take you through this. Just one thing that I noticed that there are not a lot of questions. So if there is any doubts as to what we are saying or anything that does not make sense, please feel free to post your questions in the Q&A or in the chat room, and we will be happy to answer them. If we are going a little bit too fast for you, please mention that also. Okay, so we can maybe go through that particular section again, right? All right, guys. So let me start with the endpoint analytics. So now this particular feature set is part of the Cisco's zero trust approach, where you want to ensure complete security within your LAN side of the network. Also, and at the same time, from the WAN side of it, we have been taking a lot of precautions already, but from the LAN side of your network, from the access side of your network, also we are coming up with approach called zero trust security, right? So you probably have seen multiple different training videos, multiple training feature videos around zero trust. This is one of the feature that makes it possible, right? And what it does is basically what we're going to share with you. So in the agenda, basically, we'll go through the challenges, why something of this sort is absolutely needed, and then what it is, and what are the different methods of deploying it, and then how we go about using it as an outcome. Okay. All right. So endpoint analytics is part of our segmentation approach, as Abhishek mentioned it briefly, that segmentation or end-to-end segmentation is the main feature of software-defined access. It gives you an automated way of segmenting your network and keeping that segmentation from one point to another point, right? And that is all automated. Now, that is true in case of users, in case of people. But what about things? Because now in the digital age of networks, we just don't have employees or we just don't have users. We also have a large chunk of network as IoT devices. And we have been successfully identifying users based on how they are logging in, who they are. Depending upon that, we were always able to group them, as employees, as HR people, as developers, auditors, whatever, right? Whichever role they came from, using ADs, Is, right? So that has been there for quite some time, and we've been doing that successfully. And SDA Access is one of the major setup that uses that approach. But what about the things? What about the IoT devices that are there in the network? Because not everything can be uh, recognized by eyes, because obviously there's not enough data for that. Eyes works on certain patterns and certain parameters. Not each device has those things. Like printers, maybe we do know what protocol printer uses, or what to expect when the printer is sending the traffic. But when you are talking about uh, things like cameras, things like scanners, things like card readers, or the smart lighting, parking sensors. So all those IoT devices that are on the network but are not being recognized by our traditional or you know conventional methods of identifying things and people. What do what do we do about that? And first of all, why do you really care? Why do you need to do anything about that? Because the thing is, we don't know what's happening on the IoT side. From the user side, we know a user would access a development server on this port, or they'd access internet on this port. They probably access a web server, and whatever services they use, we more or less know that, because obviously uh, there is specific work that they need to accomplish, and there are certain applications they are going to use for that, and then we can predict that, and we can create our policies around that. And that's where you need this information, right? To create policies, to create segmentation. But if you do not know which IoT device is there in the network, and then after that, you do not even know which IoT device is going to talk to which particular service and which particular protocols are they using. So all that information, when you do not know about that, what you're losing on is segmentation, because if you don't know what they are using as a protocol to communicate, or what services are they going for, then you really can't segment things properly. That really keeps a bigger uh, you know option to make your network vulnerable, because if you do not know what to secure and what to allow, then you are essentially allowing more services, or more it's more open network between those devices that can be exploited by a lot of different types of attacks. The attack vector has changed today in today's world. Earlier, there were only a couple of types of attacks prominently, but now, the malwares are there, the different types of ransomware are there, uh, different types of identity attacks are there. So all those things make it even more important that we know what's happening in our network, right? So that is where this particular idea of identifying devices came into the picture. So if you look at this slide is basically telling on the left side of the screen, you have your whole network. This is what your network looks like, probably, because you have users, you have contractors, guests, you have servers, then you have things like cameras, your HVAC systems, printers, and everything. But when you really start segmenting, you only segment mostly your users. Maybe you can identify certain devices like mobile phones, or the tablets, because of the MDM setup that you have. But if you talk about the things or the IoT devices, most of them are unknown. And if they are unknown, then you don't know what they are talking, what services are they using, right? So that's where the problem comes into the picture. So that is why the visibility into your network is very, very important. So here is a report which talks about uh, you know the current landscape. So in 2021, which we are already in, there would be 25 billion devices within the IoT, right? So that's already happening, because you're already in 2021. Then 83% of the devices which are IoT devices or imaging devices, primarily used in things like medical services, hospitals. Because hospital, if you look at hospital network, they are most of the devices are IoT devices, right? They are medical equipments, the machines, the scanners, the different diagnostic tools. All of those are IoT devices. They are connected to the network, but they do not necessarily run the similar OSs that we have in the user systems as of now. Most of them are so old that we do not have any markers for them in eyes to really find them or profile them. So 83% of the devices do not run supported OSS, or even if they run OSS, same OSS, they do not run same protocol. So that's basically is the current scenario. And 98% of the IoT traffic is unencrypted. That means it is more easier to uh, spoof it, more vulnerable to attacks. So that's where this visibility becomes even more important, right? So because if you have so many devices in your network which are sending unencrypted traffic, which are unsecure, and you do not know which OS they're using, what kind of traffic they're sending, that becomes a big security loophole. So that's what we are trying to do, connecting machines and people securely. So we have been doing that for people, for the users, for quite some time. For machines also, we want to do that, and that's where this concept of endpoint analytics came into the picture, right? So we want to understand not just who is logging to the network, we also want to understand what is using the network and for what purposes, right? So whether it's an imaging machine, whether it's an MRI machine, whether it's the smart lighting, the smart parking system, or just an access card reader, or maybe a security camera. We want to understand all those things. So this is the approach we are taking to answer this concern. First, we want to understand which endpoints are we really using in our network, what all different types of endpoints do we have, right? And after we know who they are, we would also want to understand what are they really talking to, what services are they using on a day-to-day basis. And based on that, we would, once we identify something, let's say in this particular example, you identified something as a camera, and then after that you can allow or deny access, whether you want to allow them to log their data into the servers and access the media servers to stream the live feed, and then what they should not have access to, right? Like employees should not be accessing cameras, so you do not want to allow that, you deny that particular thing. Okay, so this is basically the approach, or this is overall idea of the feature that I'm going to talk about first, and then second feature is complementary to that also. So both of the features that I'm going to talk about during the course of this presentation follow this approach. The first feature, which is endpoint analytics, falls into the know your endpoints. Second one, obviously the GVPA falls into kind of both of these things, right? You see what they talk to, and then obviously you assign or create a policy. Okay. So before I get into the endpoints, any questions about the challenge that we discussed so far? I mean, anything that does not make sense? Okay, let's proceed. So endpoint analytics is the next phase of endpoint visibility. We are going to use the AI-driven analytics and deep packet inspection to find out what are the different types of endpoints that are connected to our network. And both of these play different roles in finding out the devices in different scenarios, right? So deep packet inspection is basically using the N-bar feature of iOS. So N-bar feature has been there for quite some time. It is network-based application recognition. We use our network to recognize what kind of application traffic is being sent. And as I said, 98% of the traffic from IoT devices is unencrypted, so it is very, very easy to find out what kind of application they're using if you are using something like NBAR. So NBAR is basically the protocol that enables our devices to look into the packet at the application layer and tell you exactly what application are being used and what kind of traffic is being generated, right? So that's the primary part of it, which takes a lot of data, processes it, and lets you know what application are being used and helps you identify the type of device and type of traffic they're sending. AI-driven analytics is also another part of it, which we will be talking about, which uses the AI and the ML features to help you identify devices where we do not have a lot of data about. Right? So what happens with this particular feature? What happens with endpoint analytics? So endpoint analytics enables you to get high fidelity profiling. When I say high fidelity profiling, what I mean is that you can granularly define and recognize the different types of devices, because we are doing deep packet inspection and we are also using the machine learning to find out what kind of devices are there, right? So it gives you more accurate results, right? You're not just using one specific parameter to find a device or recognize a device. There are multiple of those. We will talk about what all those are in the upcoming slides, right? So we also use crowdsourcing using the AI to help identify devices that are largely unknown for now, or maybe using some new protocol that is, or new application that is not already predefined into the NBAR engine, right? So that's where the crowdsourcing comes into the picture. We also can get additional context from Cisco ICE. Obviously, Cisco ICE does have certain markers, certain attributes that help us identify devices. We can also use those attributes to get a clearer picture or a more accurate profile for the device. Improved classification, as I said, that's also part of the high fidelity profiling. You have 1400 plus application protocols as part of the deep packet inspection engine NBAR. So NBAR already has this many number of known applications that it can read and tell you, what kind of traffic is being sent using those applications. So that's already there in the database for NBAR. And AI and ML clustering reduces unknown endpoints. So that's something that's also part of our AI engine. And multi-factor classifications of endpoint. So whenever we are using deep packet inspection, we are not just using one attribute, as I said, we are using multiple different attributes. So I'll show you what all those are in upcoming slides. Better workflow with integration. So this is basically for if you have any asset management applications that you are using, or which already has a database of different things or devices within your network. A lot of companies do that. Big organizations use applications like ServiceNow, where they have all the database of different devices that they have. They use that for asset management or for device tracking. So those applications, basically for now, we have integration with ServiceNow. We can integrate with ServiceNow, and this integration helps us get that context from the ServiceNow. So it's a one-way integration. We can only pull data from ServiceNow of the different device profiles that you have created there, and use that as a classification marker for identifying our devices. So that's where the ServiceNow comes into the picture. Obviously, ICE we already talked about. So ICE integration is required for two reasons. One, to give you that context, okay, this device is authenticated like this was the attribute and all those things. Other than that, you also need ICE as an enforcer mechanism. So after you identify devices using endpoint analytics, okay, let's say this device is a camera or a parking machine or a MRI machine. After that, what you want to do with that information can be done only using ICE integration. So that's why ICE is something that you need as an enforcer. Is there any question? Okay. Okay, so let's proceed further. So now, endpoint analytics for DNA Center. Basically, endpoint analytics, if you look at this picture right here, it works with endpoint profiling. And to get this endpoint profiling, what we need to do is, there are two ways of doing it. One is data aggregation, which is obviously based on the collection of the data from your network. And the second is machine learning analytics. So machine learning analytics is the second part of it. So most of your work happens here, data aggregation, because obviously, as I said, our NBAR engine has more than 1400 application fingerprints already. So using deep packet inspection, we will be able to identify most of those devices. I'd say 90% of those applications, because NBAR was a protocol that was created to focus on applications that are being used in the businesses. There are multiple different classifications on those applications. So it already has a very huge database of the applications that are popularly used. Then we don't just use NBAR, we have network telemetry probes that are being used between DNAC, and obviously ICE also provides that information. We have easy onboarding tools like for automation for the endpoint analytics, that's also available there. And then CMDB connector that I was talking about is configuration management database. CMDB connector is basically an identifier. Like you can just say, we're talking about ServiceNow here, because as of now, only ServiceNow is the CMDB connector that we can integrate to as of now, right? There are multiple different asset management applications out there, but ServiceNow is what you can integrate for now and get the data from, right? So all these data points basically help us do the data aggregation, and out of which we will be able to identify 90 to 95% of your network. But if there is a device that cannot be identified by all these data collection point, or if it is using a protocol that's not standard, or it's using an application that is not really very well known, that's where the machine learning analytics comes into the picture. The machine learning analytics helps us group multiple similar types of traffic into a cluster, and based on that, we can later on identify what kind of device it is, right? So we'll talk about this in upcoming slide. Yes. Hey, Baitao, could you please mute yourself? I think there's some disturbance coming from your side. Baitao, are you there? I think Ray, you made him the presenter, or the host.
Oh, because
yeah, so he needs to go on mute.
I think you go ahead first, because I think he's typing the keyboard.
Okay, no problem. All right, so using these two different mechanisms, right? The data aggregation and machine learning analytics, we will be able to identify most of our network devices, and that's what the endpoint analytics is focused on. So majorly, if you are talking about endpoint analytics as a feature from DNA Center, and if you want to understand how it works, you need to look at this picture right here. It simplifies how it works. It basically uses data aggregation from all these different point of data collections. And then at the same time, it also uses machine learning analytics for things that cannot be defined or are not known through the data aggregation, right? So let's move. Okay. So we were talking about multi-factor classification. That is what is using when you are doing your deep packet inspection. So when you are doing deep packet inspection using NBAR, these are the different classifications that are used: device types, hardware model, hardware manufacturer, and operating system. So if you have been using ICE, or if you have had any experiences with ICE or any any AAA server that is out there, you normally use one classifier to find your devices, right? You say, okay, IP address or device type or the building location, or maybe the protocol that they're using, maybe you're using a Radius or LDAP to do that, but you use those protocols to, and one of the markers, one of the classifiers to identify your device, and based on that you take an action, or you allow traffic, you assign a VLAN, let them connect to SSID, whatever. That's basically what you do. But that is limited to majorly one or two attributes. But here we have multiple attributes that we are checking, right? So that in turn means that we would be able to classify our devices very, very accurately. So if you look at this example here, so it's talking about 3 different devices. So in the device type, we found that one of the devices was laptop, one is CT scanner, another one is smartphone. And then we also check the model of those devices. So whether it's a MacBook Pro, if it is a Ultima scanner, right? And then Galaxy S8 smartphone. Then who was the manufacturer? And at the same time, which operating system is being run. Now, all this information is coming through DPI or the NBAR engine. At the same time, endpoint analytics or the DPI engine that we have is supporting multiple protocols that were not supported earlier, that the DPI did not understand earlier. So those protocols are, majorly those 2 protocols that are being focused on right now are DICOM and HSN. There are more protocols that are being added, that are protocols that are very, very prominently used in the medical devices, or the devices that are IoTs. But there are more protocols that are being added so that we can recognize devices very, very accurately. So this multi-factor classification helps us identify devices with a very, very accurate information. Because if you remember from ICE days, you define, okay, a Samsung phone or an Apple phone, you don't really define which model it is, right? You don't really define which OS it is running. You can, but then that's additional steps. So if you have MDM integration, then you have more and more features available. But as in standalone option, there are less options available. And for the phones, that is still true. But if you're talking about a CT scanner, or maybe a smart lightning setup, or maybe access card reader, or a security camera, then it becomes much less descriptive. So endpoint analytics gives you that leverage or that additional information that you need. So let's see how it happens. So classification based on deep packet inspection. So in this scenario, what we are using, you're using a CT scanner, which probably is installed in a hospital. So when the CT scanner sends some traffic, obviously for DHCP, and ICE authentication happens, all ICE gets whatever, like, let's say you are using MAB or something to identify it. ICE will identify it as MAB, allow the traffic, IP address will come. And once the IP address is there and CT scanner starts sending traffic, the deep packet inspection on our Cat9K devices, or the NBAR, which is the protocol, the NBAR is going to kick in and look at the data packet. The data packet will see that the protocol that is being used is DICOM. As I was saying, DICOM is the protocol that we now can read. So DICOM is the protocol that is being used to communicate. And then with DICOM protocol information, we will be able to figure out that it is CT540, that's the model, right? And we will be able to fill in all our multi-factor classification identifiers. We'll be able to identify whether it's a CT scanner, who was the manufacturer, what kind of model it is, then what operating system it is running, right? Basically, this is what is happening with NBAR. And if you see, it is running on your switch. So all your edge nodes that are there in your fabric network, they will be running NBAR engine by default once you enable the endpoint analytics. Okay, so with machine learning, so this was, let's just go back. So this example was for the first part. As I said, the endpoint analytics is made of 2 main things. One is data aggregation. Second is machine learning. So this is an example of data aggregation where the data is being picked up from the network devices, which is obviously the Catalyst 9K, and being fed to the endpoint analytics engine here on the DNA center. And then DNA center, looks at the endpoint analytics engine looks at this information and finds you that classification information, right? And identifies your devices. But what if the device that is being tracked in the network, it is an unknown device? What happens then, right? So in this case, so let's say endpoint analytics is getting information from the multiple devices within your network. Now, iPhones is a pretty common device now, right? So iPhone will be identified based on whatever protocol or whatever database that we have, right? Or device data lake, they're calling it. It's the database basically, which endpoint analytics has. But for the unknown devices, what it will do is it will group them. It will group them based on what kind of traffic they're sending, what kind of behavior they have, right? You see it grouped two set of devices into two different groups. One is orange and one is green. Based on the orange and the green groups, it will tell you, it will not you or basically whoever is managing the DNAC, it will tell you that I recognized two different sets of clusters within your network. However, we do not have any specific identification level for them. Do you want to identify them as something? Now, the option to identify them comes to the admin. That would be you, right? So admin will go ahead and say whether these are coffee machines or Apple watches or cameras or whatever. You decide that. So this is for the devices that we do not know what protocol they're using and or they're not really very well known endpoints or IoT devices in the market. So that classifications come to the admin. Now, once admin identifies them, so once that is done, AI engine or the endpoint analytics engine within the DNA center will go ahead and talk to the Cisco AI cloud and inform about the labels that were selected by the admin. It will say, okay, this particular DNAC has this particular endpoint analytics engine, and the admin on this particular DNAC assigned this traffic as a Bosch coffee machine or as an Apple Watch, and that information is stored into the cloud. Now, if it is stored into the cloud, AI already has this information now, right? So what happens next is, if let's say company B also has Bosch coffee machines, so the similar process will happen there also. And when they get this option to recognize devices, they'll also get a suggestion. They'll get, hey, admin, I think this is Bosch coffee machine. Do you want to confirm that, or do you think it's a different thing? So the admin will obviously look at the devices because they know what devices these are based on IP address, based on location. And they'll say, okay, yeah, these are coffee machines or these are something else. And depending upon that, the AI will update it, right? So here is the example. So customer A said that these were Bosch coffee machines, and AI cloud is now aware of this. Customer B also got the same cluster. So AI will recommend the label saying, okay, these are Bosch coffee machines. Do you want to confirm that? If they confirm it, good. If they don't, then that information gets fed into the AI cloud and says, okay, we need more information as this is being defined as this particular different device, whatever device they chose, right? So that's what the crowdsourcing is. So if you look at this particular scenario or the flow that we talked about, there are two major factors. One is AI, AI-based DPI or deep packet inspection, which basically works on these four parameters: device type, hardware model, hardware manufacturer, and operating system. These are the primary identifiers that we need to identify a device. If not, then we go into the machine learning mode where we cluster the devices, and after the clustering, we go ahead and ask the administrator, and administrator is going to provide us those labels, right? What happens after you are aware of these things? Now you have already identified the devices. That is the job half done, right? You know now what devices you have in your network. What do you do with that information? What you do with that information is you use that information to secure your network. And how you secure your network is how you allow those devices to communicate within the network. To do that, you basically integrate your Cisco Identity Services Engine with the DNS Center, which is obviously a must in any case if you're doing software-defined access. So you need to have Cisco ICE, because Cisco ICE will be used as an enforcer, because endpoint engine is not, endpoint analytics is not really doing any policy. It is just identifying devices for you. The policies are always done at the ICE from a DNS Center perspective, because ICE is the policy engine for DNS Center, right? So once you have all that information, I'm not sure if you are aware about how integration between ICE and DNS Center works. So let me just quickly tell you how it works. So we basically integrate ICE and DNS Center using PX Grid and REST APIs. So PX Grid is a protocol, platform exchange protocol. So what it does basically creates a publisher and subscriber relationship in which both DNS Center and ICE will be working as both publishers and subscribers to exchange information and to use that information for creating outcomes. Like for ICE in this case will provide information about the attributes that it discovered when it was authenticating, like MAC address or whatever. It will provide that information to endpoint analytics. Endpoint analytics will use that information to identify the device and obviously use its own artificial intelligence engine with the packet inspection to find out what device it is. And after it has classified, okay, this device is, let's say, an IoT device, a security camera, that information is being fed back to the ICE. Now, ICE will have this information. Based on information, we need to create our policies. As of now, this particular policy creation, the points that you look at right here on the right side of the screen, blue and green, these 2 points will have to be done manually, because obviously EA is a new feature. So we're not automating everything as of now, but in future we will be. So that's already being worked upon. It's going to be automated in upcoming releases. But for now, if you test it in the current lab or current version, it is the ICE part of it will have to be done manually. So you'll have to create a custom endpoint policy based on the attributes that we collected here, based on the information that's being fed to the ICE. You can create a custom endpoint policy saying, okay, if you find all those markers, the attributes, that's the device. The device type is, let's say the security camera. And based on that, you can create your authorization policy, because now you know that the traffic that's coming from this particular device type is actually a security camera, and this particular security camera, and not, maybe a coffee machine or Apple Watch. And according to that, you create your more specific authorization policy that basically gives you a very, very controlled environment, which can only have access to what you are allowing using your policy. So that brings me to the deployment models. Let me check if there is any question. Okay. All right. So deployment models, how it really works. So what happens here is basically we're talking about a wired endpoint in this case. Your devices will be connecting to your Cat9K, because those are your switches which would be facing the end users. They will do whether .1x or MAB. With the fabric, you need to either do .1x or MAB. That's how it is recommended. So once you do that, that information goes to the ICE. Then ICE will authenticate and send you back the primary policy, basically saying, okay, you are good to get this IP address and you are able to connect to the network. And it will also send that information saying, okay, this particular guy with this MAC address authenticated, and here you go to the endpoint analytics. Then when this traffic is being sent from the .1x from the endpoints to the switch, that's data traffic. Let's say they're talking to the server or they're trying to onboard. That data traffic comes to this the 9K switch, and that 9K switch has the N-bar engine. That N-bar engine will go ahead and look at the packet at the application level and will send that information to the DNA center, to the endpoint analytics engine. And that's how it will know that, okay, which type of device it is, right? So that endpoint label information that comes into the DNA center, and then DNA center goes back and sends the information to the ICE saying, okay, this device is a CT scanner with this particular manufacturer, this particular model, and that's the OS. Now on the Cisco ICE, now you have a very accurate profile of the device. Now you can change, if you want to change, let's say, earlier you were just doing a map, so you just gave them an IP address. Now if you have a dedicated VLAN for, let's say, CT scanners, then you can go ahead and make that change and push that policy again. The device will be assigned to that particular VLAN or that particular SGT or group, right? So that's what is overall process flow is going to look like. So if you remember, if you want to maybe simplify or relate this example to something, like how you onboard BYOD devices, right? You first put them in the, let's say, guest VLAN or a major VLAN where everybody is and has limited access, and after that they authenticate, they register themselves, go through the BYOD flow, and then you assign them the enterprise VLAN. Similar to that, this is what is happening here, right? But now it's more of from the device or endpoint perspective, not from the user perspective. The user perspective was already working. For the wireless, we are only doing it for the 9800s as of now, because those have the N-bar engine within them. So similar thing will happen. Wireless endpoint will authenticate using the wireless LAN controller. ICE will provide the policy, primary policy, to connect to the network. Then the data packet comes into the picture. It gets inspected. The inspection engine will let endpoint analytics know what kind of traffic it is, what device it is, and that information is being fed back to ICE. And then ICE will go ahead and take an action, saying, okay, you are not part of this particular group, you should be part of thermostat group. Go ahead and change to this particular pool, and then depending upon that pool, you have all the policies and everything, right? So that's what you do. Okay, what happens if you have a third-party infrastructure? So until now, we were talking about all Cisco Cat 9K switches or Cat 9800 wireless LAN controller. But what if you do not have any of those in your network, but you do have a DNA center? Or you have legacy devices which cannot do N-bar. What do you do in that case? In that case, we have an option of a device, a physical form factor device called telemetry appliance, traffic telemetry appliance. So it can do multiple things, but in this case, in this scenario, it will also do endpoint profiling for you. So traffic telemetry appliance will have to be placed in the distribution layer where it can have access to all the access layer within your network. And it can only talk the span or R-span for now. So we are also trying to do ER-span. That should be coming out in upcoming features, upcoming releases. So you'll be spanning your distribution layer into the TTA, and then TTA will be recognizing doing the deep packet inspection for you, and then it will feed that information back to the endpoint and analysis in the DNA center. So this is a physical device, Again, if you already have a DNA center and you have devices that can support NBAR engine, then you do not need to buy it. But if you have a mixture of third-party devices and you do not have devices that do NBAR as of now, then yes, you need to have this particular device. It's a separate hardware appliance that needs to be bought separately, right? Or you can check. If any of your customers have this need, you can contact your Cisco teams and they will help you, identify the cost and other stuff for it. But it is already out there. You can use it for getting all this information. Nothing changes. It still remains same. The traffic comes from your network into the TTA through span. After the initial policy, the TTA sends back that information to the endpoint analysis engine in the DNAC, and then DNAC feeds the information back to the ICE. And obviously, based on that, you can do the policy change and onboarding change for the endpoints. So here are the requirements. You need to have minimum DNA center 2113 plus. Obviously, now the recommended is I think 2124 or 2125. So you can go for that. That would have it. The ICE version and the patches. So very, very important point. People who have been doing SDA, they would know. With DNA center and ICE integration, you have always need to be very, very critical about the patches, right? The version within one major version like 2.7 or 2.6, there can be maybe 10 different patches or maybe 20 different patches, but only specific patches work with the specific features of DNA center. So you need to ensure that you are running the patches that are recommended. Otherwise, you'll always have irritable outcomes. So you might not get the right outcome when you are looking at the reports, or integration might not work also. The device types that are required as of now for wired NBAR, you need to have Catalyst 9200, 9600, or 9400. The minimum code is 1731. Same thing for wireless, you need to have Catalyst 9800 WLC, 1731 is the minimum code. Then obviously if you want to have, if you do not have these devices, then you need to have TTA. TTA is, here is the part code for it. If you have access to CCW, you can go ahead and check the pricing and everything here. And then the availability is already there. So it's been out, it's been out there for a couple of months now. So you can always go ahead and order it. Okay, so it's just a quick demo. Not going to show you a real live example. It's just some presentation screenshot that we have taken. Right, so we basically go into the endpoint analytics, which is under the policy. After that, so this is what you would see when you are on this particular screen, right? You would see overview, endpoint inventory, profiling, hierarchy, all these things. And if you see here, you see unknown devices, missing profiles. Sorry, I think it's going a bit fast. Just a minute, let me come out of presentation mode. Okay, so you go into the policy, and then in policy, you go into the endpoint analytics. I'm not sure why it's going black in the. Okay, so let me just. So as soon as I go full screen, it stops, but that's okay. Let me just show you here itself.
So we can try to maximize it here at the bottom.
Yeah, that. Okay. So if you see here, you see three different types of outcomes there, right? So when you enable the endpoint analysis engine, it shows you three different types of results. Right now, it is trying to identify different endpoints within your network. So you see it is showing you an unknown, missing profiles, and fully profiled. Fully profiled are the devices that analytics engine was able to accurately identify with all the four markers of all four form factors that we were looking at, right? So these devices are fully profiled. Missing profiles are the devices where at least one of those form factors were not being collected. And the unknowns are obviously unknown where we do not have any other marker at all. So that's basically what you would see here, right? So let's proceed. So you have endpoint inventory profiling rules and hierarchy. But right now, obviously, not all of these things really make sense. So you can see all your devices right here, right? And then if you click on any of those devices, so here you can see it's a full body CT system. Then what's the model number? What's the hardware manufacturer? So here you see there is OS is missing. So this device is probably not fully profiled. So it has 3 of 4 markers. So we need to have all 4 markers for it to provide that information. And then you can see the protocol. It is also recognizing the protocol that you are or this particular user or device is using. It's DICOM. And what kind of device information it is. So right now it's not telling you the OS, and that's why you do not know the OS. So to feed this information back to ICE, we use this particular label, IoT asset. And within IoT asset, we are going to inform about the type, the hardware version, the address, and all that information back to the ICE. So basically, using these identifying markers, you can go ahead and create your ICE policy to identify these devices and to get more granular with your service. Okay, so for the devices that are suggested devices, so let's see what. In this example, what we are going to do is we are going to take the example of second option, the machine learning. The first one was for deep packet inspection, where you were collecting data, aggregating it, and coming out with an outcome, saying, okay, this is a scanner. But in case you do not know what that device is, that's what is happening here. So this DNA center has identified 812 devices that are using a similar, they are from similar manufacturer, they're using a similar DHCP class identifier, and they're also sending similar type of traffic, right? So, but it does not know which device it is. So that's what we are going to identify or help it identify, right? So it is using that logic. And then it gives you the option that, okay, this is, in the summary, if you see, this is telling you, okay, this is the device type and these are the information that I have. Now you need to help it identify what exactly it is. So it is telling you the suggestions, but you need to confirm the suggestions, right? Is you can change that information also if you want to, but more or less it will already suggest you with based on whatever information is available on the AI cloud, right? So they have created the policy information, and that's it. So this policy is not really being pushed to ICE. This is just to identify the device within DNA center as of now. This process will be automated for ICE also going forward. You will be able to push these policies within ICE. Don't look at this part of it because this is group-based access control. You might not be able to understand it for now. We will be talking about this after the session, in the next session, right? So that's what we are going into next. So basically, for the endpoint profiling,
when we were here, let me stop. Yeah. So right here where you are providing this information, it is actually giving you the different identifiers that it was able to collect using the cloud and showing you those suggestions. You select those and confirm that okay, this is the device type. But this policy, this profiling policy will not be replicated on ICE. You need to do that manually as of today. But as I mentioned, that this is something that we are going to automate. That's already being worked upon. So I think in upcoming releases, as soon as this come out, we'll make that announcement. And you will be able to use these attributes within ICE without any problems, right? To create your policies. And then you'll not have to go ahead and create those custom endpoint profiles and then the authorization policy manually. You'll just be able to find them in ICE and you'll be able to use them from the drop down and identify those and create those policies automatically. All right, so that's pretty much what we wanted to talk about in the endpoint analysis. So let me take a pause here and see if you guys have any questions. And then after that, we will talk about the group-based policy analysis, which is the second part of it, which is also very important. And if you remember the slide where we were talking about know what devices do you have in your network, see what they talk about. So we are now at the C part of it, the second and the third part of it. So before we get into this part, let me see. So I don't see any questions in the Q&A panel and nothing in the chat room either. All right, so let me proceed in that case. Okay, so group-based policy analytics. So until now, you have collected all the information and now you know what devices they are. But what you don't know as of now is what do they talk about or what do they talk to? You know that it is using a DICOM protocol, but with the DICOM protocol, what all services it is accessing, what all destination it is using to that, going to use, what all other protocols apart from DICOM are open between your CT scanners and your medical, backup servers, or maybe between doctors and the scanners. So whatever it is, right? So you need to find that information. So that's where the group-based policy analytics comes into the picture. So that's another feature that we have introduced within DNA Center in 2.x. So this particular feature helps you find the flows within two different groups. Now those groups could be the SGTs. I'm not sure if you guys are aware of the SGTs. SGTs are scalable group tags within the SDA. Scalable groups are the groups of endpoints which are sending, which are basically users or your endpoints, and which are similar in nature, right? When I say similar in nature, is basically sending similar type of traffic or accessing similar resources within your network, right? So we would be able to generate this flow visibility graph where we would be able to see what those groups are talking to and how they are using our network, right? So if you look at this example here, you can see different SGTs right here: critical medical devices, entertainment devices. Then you have image management, and on the right side you also have different types of all those different tags, right? Based on this outcome, you can decide who will be talking to what. So let's proceed. So what this helps us achieve? So first, let's understand the challenge. The challenge is basically the high-profile attacks as of today. So as I was saying, when we were talking about the challenges during the endpoint analytics discussion, I mentioned that we do not know what devices do we have, and we do not know, if we don't know what devices do we have, we don't know what they're talking about, what services are open. And that is one of the major reasons why IoT networks are a bit scary, because people don't know what traffic to allow. And then when they don't know what traffic to allow, they normally tend to open a bigger service pool than they should be. And then that helps the people who are trying to attack your network to easily get into your network. Anybody can, just disconnect a security camera from its connection and connect a laptop there, spoof the MAC address, and then act as a security camera and have access to your network, because now the IoT device, this camera was feeding information to the server in the data center, and then from that server also being accessed by different security stuff. So people can access, or the hackers can actually use that path to attack your network. And that has happened in past. People have exploited those vulnerabilities. And that is one of the major challenges. As I said, internal networks, we do not know what is being used, specifically when it comes to IoT, not everything else. Users, we are more or less aware in so many years of networking. We are now very, very accurate as to what all should be allowed. At least, and I'd say up to 80 to 90%, not 100% there, obviously. But yes, with zero trust, yes, you would be able to achieve that soon. Difficult to understand behavior of the devices, right? Even though you know what all devices are there, you know what protocols they're using, but you do not classify exactly what services, what port range are being used. So that's something that is where we still need to kind of evolve and create our policies according to that. And then those policies can only be created if we are aware what kind of traffic is being sent by these devices, which is what the GBPA or the group-based policy analysis brings to us, right? So this solution is going to be done in different phases. The first phase is discovery, where we are going to analyze the traffic and tell you what kind of traffic is being sent over between two different tags throughout your network. So that is the discovery phase, and that is where we are. If you see here, it says first release, we just covered discovery. And that is where we are. As of today, the group-based policy analysis can tell you what is being communicated between two different sets of devices within your network. We cannot automate the policies based on that as of now. That has to be done manually. We will be able to do that in future. That's the roadmap item. And we will be able to micro-segment the network automatically also in the future. But that's something as of now is all manual. You can do that for sure, but manually. Okay. So this is how the group-based policy analytics works. Basically, your DNA center is where you have all your SGTs and the information about the policies. And that information is coming from ICE, because ICE is the policy engine. ICE has the SGTs, and ICE provides that information to DNI. But in the newer code 133 and above, you will be able to manage that policy part of ICE, TrustSec policy part of ICE with DNS Center, right? So you are able to see all those SGTs. You can create those policies within DNS Center. So to get that information, SGT information comes from ICE. Then StealthWatch host groups are also there. So if you have integrated your DNAC with StealthWatch, DNAC will be able to see the host groups also that you create in StealthWatch, which are like the different types of network devices that you are monitoring through StealthWatch also. Those host groups can also be seen here. The endpoint analytics, multi-factor classification. This is something that is still being worked upon. We are working on it. It's going to be out there, I think, by next code or something, but it is being worked upon. So you will be able to see the endpoints that were classified by the deep packet inspection also as the identifiers. So you can also see traffic between those. But for now, the SGTs and host groups are already there. You would be able to see that. So you will see something similar to this. So you'll see multiple flows. And if you click on any of these SGTs, it will tell you what all traffic is being sent to which all tags. And if you click on any of those pipes, it will tell you what protocols are being used, right? So let's see. So basically, this is just your flow, how you enable it. You just have to have connections to ICE or StealthWatch, basically one of those. And you need to enable NetFlow. This works on the flexible NetFlow. As endpoint analytics was working on NBAR, which is an application engine or a service engine within the switch processing. NetFlow is a protocol that needs to be enabled on the network devices for the group-based policy analysis to work, right? So once you do that, so this particular process is automated also. You can do that by DNA Center. There's not much you need to do. Pretty straightforward. If you are running an older code, there are certain things that you need to do before you enable NetFlow, but in the new code, it is all automated. So once you have enabled it, the discovery will obviously happen based on the traffic that is, or the FNF information that is coming to the group-based policy analysis engine in the DNAC. And depending upon that, all the protocols are being analyzed and what all flows are being sent out from between from SGTs to SGTs. You will be able to analyze all those. This third part, compare contracts and create policy, it is manual as of now. It will be automated going forward. You'll be able to, for now, you'll be able to visualize the patterns. You'll be able to see two different tags and what they are trying to access. So this is basically the flows that you can see between the groups and profiles, between the profiles and the groups, between the ICE groups, SGTs, and the host groups of StealthWatch, or StealthWatch groups to ICE. So you can create different patterns to see what kind of traffic is flowing between them. So these pipelines, like here, if you click on that, a pipe between MRI and PAC machine, so you would see that what kind of protocols they are using, right? So TCP 104, 112. So right now, earlier we were only aware that MRI machine and the maybe the scanner system was talking, but sorry, the auditor system was talking, but we did not know what ports they were using. We probably knew what protocol, but we did not know what port they were using. So this is what we will be able to see now with the group-based policy analysis. It will tell you exactly what protocols are they using, right? And if you click on view contract right here between MRI and PAC machine, it will tell you what contract that you have created. So if you see, you created this particular contract, which is port 135, 3389, 23, and this. Okay, so you're denying all these and probably allowing everything else. But if you look at the traffic flow, only these ports are being used. So now if you look at this particular information, this tells you what's missing in your network, right? What is the security loophole in your network? That you are probably denying specific ports, but you do not know that it only needs to talk on these ports. So once you do this, you will tighten the security in your network, and that brings your network to a stage where it does not allow anything other than what's necessary, right? So that's what a zero trust network is, right? Basically, you deny everything other than what needs to be allowed. So that's the zero trust method, right? So since you're using only 3 ports, you will be able to, you can just go into the policies in ICE, sorry, not ICE, in DNA Center, in group-based policies, and update your contracts, basically, depending upon this. As of now, this process is not automated of changing the policy, but yes, you will be able to do that in future, right? So the final step is to change contract and policy. That is still manual, but we'll be able to do that in future. So here is the hardware and software requirement. So you need to have at least 2.1.1 or above, right? So again, as I said, 2.1.2.5 is I think the recommended one right now. So you can go for that. And the ICE version is mentioned right here, and the StealthWatch version is mentioned right here also. Again, StealthWatch is not necessary. If you have StealthWatch within your network and it is integrated to DNAC, that's when you will be able to see the flows between the host groups and the SGTs. Otherwise, it's just the SGTs. And for endpoint analysis, multi-factor classifications, you will be able to see those information also in future. As of now, it's being worked upon. Okay, so this brings us into the same picture as we were talking about earlier in the very beginning of this particular presentation, that with endpoint analytics, we are able to see what is there in our network, what is using our network actually. So that's endpoint visibility, right? And then with the group-based policy analysis, we are able to see what are they talking about, or what are they talking to, what protocol, what services. And then that brings us to trust analytics, where we know exactly what our network is doing, and we are securing our network based on the outcomes that we have collected from both of these features, right? So here are certain documents, basically white papers and some of the demos that are already there. So you can access these resources. We will be sharing these PPTs at the end of the day. We'll upload them to WebEx Teams room that is created, and you can download from there. And we also have a demo in the D Cloud. You can always go ahead and book it. It is a quick demo, always on kind of a demo. So you can just go to D Cloud and access this. And same thing for group-based policy analysis. We have deployment guide and the TDM. So that's pretty much it. Let me see. I think there was a question. Okay. Yes. For the MAC randomization, so question is, can it identify devices with MAC randomization mode on? Yes, that would be possible. Sandhan has already answered it. So it would be able to identify because it's not dependent upon the MAC. It is dependent upon the information using the NBAR. So NBAR is looking at the application level, right? So if you're looking at the layer 7, layer 1 or layer 2 information does not really matter all that much. So MAC address is just an identifier from ICE's perspective, but we're not using MAC address as an identifier. If you look at the endpoint analysis, the 4 form factors and the 4 multi-factor things that we use for identification, MAC address is nowhere in that. So, yeah. So we use device type, hardware model, manufacturer, and the operating system. So you don't have to worry about it. And none of this information is collected from the MAC. It is collected from the DPI or the deep packet inspection. Okay. All right, guys. So if there are no more questions, we are done with the second presentation. Now we have 2 more topics to go to. Let me see the time. So is this the lunch time for you guys, or do you want a short break and then we can come back again? How do you want to go about it? I think it's 11:42 in Hong Kong time. Ray, Baidao, anybody can help me with that?
Maybe we can take a lunch break at the early time, and then we can come back 1:30 or 2 o'clock.
When do you want to take the lunch break? Is it right now or
depends on yours. Yeah. 12:30.
So
or 12.
Yeah, 12:30 is fine. So if you want to do, let's say 12:40, I'd say, because we have about 40 minutes of content left. So do you want to give them a 10 minutes break right now, or shall I continue?
Okay. Depends on your arrangement. I think they should be fine. Yeah.
Okay, so let's maybe just give them a 5 minutes break, right? Just to get some water or coffee, and then we will start. Okay. So right now it's 11:42, I think 11:42, 11:44. So let's start at 11:50 your time. I'll bring up another presentation meanwhile. Okay, so 11:50, 5 minutes from now, I'll start. Just go get some water or tea for yourself. And then we will give you a lunch break after that. Thanks. Okay, guys, I think we can start now. All right. So now we are into the next part of our training agenda for today. So far we have discussed the updates on 2.x version, and after that we discussed about the endpoint analytics and group-based policy analytics. All of those were basically focused around the features or the updates on the DNA center itself. Now the next two topics for today are mainly focused around the integrations that DNA center offers. So we mentioned a bit about StealthWatch when we were talking about the GBPA previously, right? So let's talk about StealthWatch analytics and integration in a little bit of more detail here, okay? So Cisco DNA Center is now providing you an integration with StealthWatch generically. I mean, you can just do that from DNA Center interface. It's automated, and it will also help you deploy StealthWatch within your network with automation. So let's see why it was required and what is it solving for us, right? So we will go through the overview, challenges, and what does StealthWatch do, and how the integration works, different prerequisites, how the solution architecture looks like, and then how it happens. So let's talk about it. So again, if you paid attention to the endpoint analytics conversation, you understand that in today's world, we have a lot of different types of network threats. I mentioned that in the digital age, the threats are also obviously smarter, right? Different types of attacks that are there that were not there maybe probably 5 years back or even 10 years back. You hear about major security breaches in major corporations all around the world, even though we invest so much in the network security, endpoint security, or threat management. So that is one of the reasons why features like endpoint analytics or even StealthWatch are very, very important, right? Because these malware attacks are majorly started from within the network. Anybody who is from the security background, who have been working on the network security, you are already aware that 80 to 90% of the attacks within the network are originated from within the network, right? They're not from outside. Outside attacks are primarily stopped by our network firewalls or perimeter security devices that we have most of the times. But the attacks that really do the damage in the network are mostly started within the network, right? So that's basically one of the reasons why products like StealthWatch are very, very important in the network these days. The zero-day attacks that use not, I mean, that's something that's you probably didn't really hear back maybe 10 years back. It was not really very, very prominent, but these days people are very, very smart finding out the vulnerabilities, the zero-day vulnerabilities of existing protocol that are already being used that were deemed secure initially, but now they still find out the loopholes or vulnerabilities and exploit them. So that's where the zero-day attack come into the picture. And traditional firewalls, traditional security devices have no way of stopping those things. We have encrypted viruses and malware attacks now, right? And the persistent threats there, which are started by AI engines. So all those things, you need a network that is smarter, that is actually monitoring at all times, not just looking for specific known attacks or known attack types. You need something that is able to tell you, okay, this does not look right. There is an anomaly, right? So that's where this particular product comes into the picture. I probably You guys have already gone through StealthWatch because StealthWatch is not really a new thing. It has been there for quite some time. This is one of the product that is also called as network as a sensor because it kind of turns your network as a sensor overall, which is looking at what kind of traffic is being flown through your network, right? So let's talk about it a little bit. So StealthWatch provides network visibility and analytics of network from a security standpoint. It is looking at all the traffic that is flowing through your network using all your network devices. It basically kind of turns all your network devices into a sensor and ingests that data, correlates it, aggregates it, and lets you know, okay, this particular traffic looks, a bit out of the picture, or there is an anomaly in this network, or there is something that is not right about this particular behavior. So that is what Cisco StealthWatch is doing for you. So it is providing you network-wide visibility. It is telling you what all devices are there, what all users are connected, how it is behaving at the moment. It is doing a predictive threat analysis at the same time by using behavioral modeling and machine learning. So it is looking at all the data that is being flown through your network from one device to another device, from one hop to another hop, and looking at it, how it is changing at each hop, and telling and predicting that you might have an attack going on or you might have something out of normal going on. And at the same time, it will also help you do automated detection from StealthWatch perspective. From a response perspective, you obviously have to integrate it something like ICE. So StealthWatch in itself is called network as a sensor approach. And if you want to make it also an enforcer, then you need to have integration with ICE. So then it becomes a network as an enforcer also, where you can create certain policies that if these threshold are exceeded, then you put that particular user or device into a quarantine or something like that. So that's basically the enforcer approach. So network as a sensor feature comes with Cisco StealthWatch. So if you look at all these different features, all of these are part of StealthWatch as a device. So it does data collection. Obviously, it is looking at the data telemetry that's coming from your network devices into the StealthWatch. It is doing behavioral modeling. Basically, it is looking at each traffic flow and telling you how this traffic is flowing throughout a different time span, and telling you exactly what the behavioral analysis of that particular traffic flow looks like. It also uses multi-layer machine learning basically to understand the behavior of different types of devices, different types of users within your network. It also talks to our security cloud, Global Threat Intelligence, which is powered by Talos. Talos is, I'm sure people who come from security background are already aware, Talos is our security cloud where everything from different security architecture within the Cisco, like Umbrella, like Zenderbase, all that information comes into that Talos security cloud. It analyzes up to 3 billion different types of malwares every day. There's a huge database of the security threats and vulnerabilities within the Talos cloud. So StealthWatch also talks to that to get more context about the behavior of different types of traffic. And at the same time, it also does encrypted traffic analysis or cognitive analysis. Encrypted traffic analysis provides you look into the traffic which is already encrypted, and obviously you might think that it will go ahead and decrypt the packet, and it might be time consuming to do that and resource intensive to do that. But StealthWatch does not do decryption. It is not going to act like an SSL proxy or something to decrypt your packet and then encrypt it again after looking into it. It basically looks at the pattern. So I'll tell you exactly what it looks into, but it looks into the pattern of different encrypted traffic, and it is able to predict which encrypted traffic is actually a malware or actually an anomaly, right? So we'll see how it happens. Basically, this is what is happening with StealthWatch. So StealthWatch is giving you visibility within your network by using your network. So you're not really, installing a firewall with this Stealthwatch. Stealthwatch is basically using your existing hardware, provided that supports the flexible net flow or FNF, and that information is collected by Stealthwatch and processed and lets you know what's happening in your network, right? So that's a very quick overview on Stealthwatch. So it can be used for malware detection, command and control threat detection, data exfiltration, threat correlation. So all these different security controls are provided by Stealthwatch, right? So mostly it is doing detection. Now how it is doing it is by using the data elements. That's what I was saying, It uses initial data packet. It uses the sequence of packet length and time. So this is an algorithm that it uses to really see at the different packets that are being sent through your devices. So let's say a user is sending some traffic to a server in the internet. So it is looking at first packet, and after that, it is also looking at the SPLT or sequence of packet length and times. How many packets are being sent within a time frame? What kind of length of the payload of those packets are? What is the byte distribution of each of those packets are? And what kind of TLS are they using? So according to that, looking at that and comparing it with the information that it gets from our cloud, it is able to identify attacks even if they are encrypted, because it can match it against the data that is available on the Talos cloud, right? So that is how it is able to do the encrypted traffic analysis for you. So it basically provides you visibility. It gives you the cryptographic assessments without ever really decrypting your packets, and faster time to response, basically, obviously, because it is looking at the behavioral modeling instead of just looking at the attacks. So a very, very successful example of Stealthwatch that I saw when there was, I think it was a few years back, 4 or 5 years back, when there was a very, very huge ransomware attack everywhere, where I think more than 65 countries were impacted by the big ransomware attack. WannaCry, I guess that's the attack that was. So during that time, Stealthwatch enabled network, where Stealthwatch was there, the detection time was only up to 13 hours, whereas the other network devices or where other network security vendors where the Stealthwatch was not there, it took them up to 6 days or even 13 days or even more time to really actually find out what was happening in the network. And the obviously the overall impact was much huge for those networks where Stealthwatch was there. So Stealthwatch gives you that faster time to response depending upon the type of attack, right? And obviously at that point of time, it was not even prepared for something like that. And now obviously it's much more prepared. Now you can detect those attacks within hours or few hours to really find out what's happening in your network, because it's looking at the behavior. It's not just looking for known attacks, right? And time and cost saving, because if you are able to find out attacks quicker, then you are able to resolve them. You are able to take those preventive measures faster, and that obviously turns up and or turns into saving cost, because if your network isn't down, obviously your network is working, and then you're earning money instead of spending money to stop that attack. Okay, so Stealthwatch gets provisioned into the day one. When you have Stealthwatch installed, then you need to obviously integrate it with DNS Center and then go ahead and provision it. But traditionally, if you are just doing Stealthwatch, you do not have a DNS Center, you go ahead and install your Stealthwatch, and after that, you have to go ahead and configure it across all your network devices which support FNF. To do that, normally it is a manual process. You have to go ahead and provide the commands for NetFlow, and you also have to provide the commands on the interfaces that you want to be monitored. So all that is done manually. Either you create a template in a notepad and do a copy paste across all your network devices, or you create a script. I mean, it is pretty basic and manual as of now. But if you use DNS Center, that goes away. So with DNS Center, what happens is StealthWatch gets integrated with the DNS Center. It's a couple of clicks that you need to do. And once you do that, DNS Center will be able to show you StealthWatch as one of the network setting devices. And then you can go ahead and push the configurations from there. So it's easiest way to enable network as a sensor or encrypted traffic analysis on both fabric and non-fabric networks. Then you can conveniently define UDP directors or flow collectors during the network design. I'll show you how. And then also automated check for whether the devices would support it or not. That is something that was missing with the manual approach, because with the manual approach, you had to make sure that the devices were running the right code, right licenses, even before you could do the copy paste. But now that is done by DNS Center for you. So when you automate, you avoid any complications, you avoid any human errors and the time consuming manual effort, right? So obviously the cost comes down for you. So how does that happen? It's basically you integrate it in your DNS Center, and you can go ahead and there's a workflow within the DNS Center now which can automate this process for you. You can provision your StealthWatch settings for each site basis. You don't have to do, you can do it globally if you want to, or you could do it each site basis. You can select, let's say, primary site number 1, site 2, building area. You can go basically very, very granular and configure different types of settings for different sites, depending upon how you want to configure them, right? Automated readiness check, I already told you about that. It's already there. It checks different parameters. I'll show you what all parameters it checks and tells you whether your devices are ready for StealthWatch configuration or not. If they are ready, then yes, you can go ahead and deploy it. And at the same time, it will tell you whether the deployment was successful or not. And then if it was not, then it will tell you why, and you can see why it was not. Security endpoint analysis, the last point here on this particular slide, that's something that is not yet there. It's a roadmap item. If you look at the top right, you'll see it's the star means roadmap, right? So basically what that means is whatever you see in the SMC or the StealthWatch Management Center for a device that is doing that is taking part in the StealthWatch traffic forwarding, that information is not shown on DNS Center as of now. We are working to integrate that part of it within the DNS Center. So soon you will be able to see what devices security levels are, what their threat ratings are, and all those that information will be shown on the DNS assurance part of it, right, with the device 360. Okay. So once you integrate your DNS Center, Cisco NetFlow version 9, that is what gets pushed to your network devices, and that enables them to forward the traffic to your StealthWatch. Now, StealthWatch can consume traffic from the UDP directors or the StealthWatch flow collectors, depending upon how you have set up your StealthWatch. That StealthWatch installation and setup is still your requirement. You need to do it. You need to get it ready. Integration. Once you integrate it, after that, the configuration part of it can be automated, right? The configuration basically on the devices, not on StealthWatch. StealthWatch host groups need to be created. Any policy that you need to create on a StealthWatch, that still needs to be created. All that still is there, right? So basically, NetFlow will be pushed on the devices, and all that information will be forwarded using UDP director and flow corrector to the SMC, and then all the correlation and the analysis will happen. And depending upon the requirement, the information goes to Cognitive Cloud or the Talos Cloud, whether it needs to do ETA or not. I mean, for ETA, it definitely goes to the Cognitive Intelligence Cloud, and then after that, you get your information. Now, that information is just there as an information. It is just doing detection. It is not taking any action. I'm saying that again, is because StealthWatch on itself cannot do that. You need to have it integrated with the ICE to take any actions. Okay, so we have a workflow to enable both network as a security and ETA on your devices, right? And I already told you about the readiness check, and you can do it by side. So let's see how it happens. Before that, let's just go through the prerequisite quickly. You need to have DNA Center Advantage license or DNA Advantage licenses on your switches. That's a prerequisite for StealthWatch and DNA Center integration, and also pushing it onto the devices. If you do not have Advantage license on your switches, you will not be able to push it. StealthWatch account is obviously required because that's how the integration will happen. So that's a must also. As I mentioned, policies and host groups are needed to be configured on StealthWatch manually. That cannot be automated as of now. I don't think there is a plan to automate that part. That's because it's a separate setup. So you need to still do it. Network devices to be discovered. So obviously, network devices should be discovered and managed by the DNS center so that you can provision them later on. And they should be added to at least one site or some site so that the configurations can be pushed, right? The device that are supported as of now for ETA and NAS, 9300, 9400, ASA 4K and ASA 1K. You see 9200 is not there is because 9200 can only support NAS. It does not do encrypted traffic analysis. So ETA stands for encrypted traffic analysis, where it can find out traffic if it is malware impacted or if it is infected traffic using even for the encrypted traffic. But that happens only for these devices and these particular iOS versions. But if you do not have these devices, then 9200, 3850, 3650, they can only act as network as a sensor. They can still take part in StealthWatch, but as sensors only. They can't do ETA, right? Encrypted traffic analysis is not a feature that is available there. So please be aware of this. Okay, so this is how the workflow works for you in DNS Center integration. So once you have deployed your StealthWatch, you go into the DNS Center, you integrate it. After you integrate it, you go into the sites on your hierarchy, you select the network settings, and within the network settings, you will see the StealthWatch option once you have integration done. And then you can choose which flow collector needs to be assigned to each site, and then the devices. After you do that, the devices prerequisite check will happen, and it will tell you if the device is ready for the installation or not, or the activation of StealthWatch or not. And if that is there, then you will be able to schedule the deployment of StealthWatch. But you can do it right now, or you can do it at a later point of day. That's of DNS Center option, scheduling option that is there for most of the configurations, right? So this is how the solution works. Right here you have your network devices. So DNS Center after integration with StealthWatch will configure these devices with the NetFlow. Once the NetFlow information is there, they will start forwarding traffic whether to a UDP director or a flow collector, depending upon your setup, how you have set up your StealthWatch. And then that information goes to the StealthWatch Management Console. Now, StealthWatch Management Console has a database which it gets from the Talos, obviously, to investigate traffic and check the patterns and everything. For anything which is encrypted and you need to analyze that traffic goes to the cognitive intelligence which is on the cloud, and then after it finds out any issues, that comes back to the SMC. And then obviously from here, if you have, let's say, ICE, which is also integrated with DNAC, you can integrate SMC with the ICE and then take actions accordingly. So this is, again, just to mention, it's a detection mechanism. For enforcement, you need ICE or some firewall to really take that action. So one of the reasons why it is successful is because most of your network solutions, network security solutions, are doing your north to south traffic analysis. There's nothing which does the lateral traffic inspection or east to west traffic inspection, right? So most of the networks, the traffic moves freely within the lateral movement. And that is where the attacks become more and more bigger, right? So again, taking the example from the same ransomware attack, most of the networks that it attacked, and it was very, very successful in attacking, was because they were not protecting or not inspecting traffic that was moving east to west. Because most of the, I mean, like if you look at the networks traditionally, the security is done at the either distribution or at the perimeter, right, or at the core level, because you want to segregate your network sites, right? You say, okay, access layer to my LAN side of your network. You want to say, okay, anything that's coming out of my LAN side of network and going out to DC or to internet, that's where I want to filter, and you place a firewall there. And then you place another firewall at the internet gateway that, okay, saying anything that's coming from outside needs to be filtered. But what about the traffic which is forwarding between the LAN side of it as also only? That traffic is moving freely. There's nothing inspecting there. Even if you have an IPS or next generation IPS, it is inspecting traffic if it reaches the IPS, right? If it is not reaching the IPS, then yes, you're not really inspecting the traffic, and that is where it is able to infect most of your machine. And that was the reason why those attacks were so large in their scale, right? But if you had something like Stealth Watch, because when you have Stealth Watch, you're enabling, let's say if you have 48 ports on the switches facing the users, all those 48 ports are actually using NetFlow to monitor the data, and that traffic is being fed into the SMC. So if one of them is behaving differently than it should be, if one of them is exceeding the threshold of the data it should be sending or whatever, that information will be triggered in Stealth Watch, and Stealth Watch then can create an alert for you or for ICE, however you want to set it up. And according to that, either you can take an action or still the ICE can go ahead and put that user into quarantine. So what will happen in that case is only that user will be impacted. So if that user was downloading, let's say, a malware, or there's already a malware that's downloaded, only that user will be able to or will be infected by it. No other machines will be infected, right? So that's the benefit basically on this stuff. I just wanted to share that because I've seen questions coming from people saying, why do we need Stealth Watch? We already have firewalls and we have next generation IPSs, URL filtering, and all those things. But just to understand that those devices, good to have. You are monitoring traffic from north to south and anything going out of your network, but you also need to think about within your network, right? So that's where this will come into the picture. And people would also argue at point that, okay, we already have antiviruses, or endpoint security. We don't need it. So again, endpoint security is looking for specific types of attacks. It is not looking at your behavior analysis or zero-day attacks. Those are things that are new, and that is something that if you have something like Stealth Watch, which is doing behavioral analysis, only that is when you can really find out what's happening, right? So that's why it becomes more and more important to have something of this sort. Okay. So this is how the workflow looks like. I've just gone through it. I'll just show you the screenshots basically. So you need to have a user for DNA Center in your Stealth Watch. So you go into the Stealth Watch settings and create a user with the access that you need to provide. Let me show you what access that you need. You need to provide configuration manager and network engineer. These are minimum two accesses that you need to provide for DNA Center so that it can go ahead and talk to SMC, right, and complete the integration. So once you do that, you go ahead and install the software update for SSA or the Stealth Watch package into the DNAC. Now again, if you're using 2.x, it is already there. You don't have to, but if you're using a version that does not have it, then yes, you need to update it. So this is what it looks like, Stealth Watch Security Analytics. just install that update. In current versions, you will see it's already there. To integrate, you go into the system settings, and then you have StealthWatch as an integration available. So in the StealthWatch integration, you provide the SMC IP, username and password, the username and password you just created earlier, right? And once that is done, DNA Center will show you this red mark, which is basically saying that, okay, we have a certificate coming from StealthWatch. Do you want to allow it? You allow it, and then it will be stored at the trusted device pool, right? And the registration will be completed. So this is how you would see it here in the trusted pool. If you look at the trusted pool, third party. But here, if you see the CN, in the CN you will see the SMC, which is obviously the StealthWatch Management Center. Okay, so this registration, once it is completed, now by default you do not have this StealthWatch Desolate. Like for ICE you already have it, for IPAM you have it, right? But for StealthWatch, if you want, you need to go into the dashboard setting of DNAC and add the StealthWatch Desolate, and then you will be able to see the status of StealthWatch connected or not, right? So this is basically something that you can do just to monitor your DNA Center integrations, different integrations. Okay, for provisioning it to the devices, you need to go into the design and network settings. Within the network settings, you need to go on the top right in the global, you'll have add servers option, and you need to enable StealthWatch there. Once you do that, you will see this particular option, which is StealthWatch flow destination. And you can click on that and select either a UDP director or flow collector, which is already integrated with your SMC. If they are not, then you will not see anywhere here. But if they are already integrated, then you will be able to see them here. And you can then just choose any of them based on which building or globally or however you want to do it. Yes, you can. You can also add external servers. So if you see here, this was an option to select it from the SMC, but if you wanted to add any external flow server or a UDP director or collector, you can just go ahead and provide that information manually and add that port, and that is it. You should be able to do that, right? So certain prerequisite that we already discussed, that device should already be discovered, assigned to site, only then it can be provisioned by DNA Center, right? So that is something that you need to have. And then you can go into the provision, and StealthWatch security analysis is one of the workflows that you will find. You have multiple workflows. We'll also talk about Umbrella in the next part of the presentation. But then you go into the SSA or StealthWatch Security Analytics. And once you click that, it shows you all those different sites. And if you click on any of the sites, it will tell you how many devices are there that are ready for this deployment, right? As I was saying, the prerequisite check. So you can select those devices. And when you select those devices, it will tell you whether required software is there, required device role is there or not. So required device role is basically access, because access is where your users are connected, right? So that's why it is important that the device role is selected as access. License requirement will also be checked. It will also check if there is any conflicting configuration. So it will tell you if there is any conflicting configuration there. So if you see here, it says in current code, SSA and SDAVC cannot work together. So if you have application visibility, which is also a feature of DNAC, if you have that enabled, you'll have to disable it so that the SSA can be enabled. Okay, so they are not working together as of now. Cisco is already aware of it and working on it, so it should be fixed soon. So once that is done, you will be able to see the deployment status, whether it is being configured or not, or whether it was successful or not, right? And then When it is done, you'll be able to see the information. What they are doing is, for now, you'd not be, let's say if you have multiple devices selected here, right now it shows only one. But if you have multiple devices selected here, let's say you had 9300, 9200s also, but 9200s cannot do ETA, right? So you can just go ahead and disable that ETA feature from there. But that is not there right now. It will be coming in the upcoming code. Right, so now you select the push to the configuration, push of the configuration of the devices right now or later on, depending upon your choice. And then once the deployment is pushed, you will see this message that it is doing it for one device. And after that, it will show you the success message, right? If you have to make any updates, you can just select the device and do an update. And basically, it's really provisioning the device again with that information, right? If you want to change, let's say, a flow collector or the status of ETA versus NAS, whatever you want to enable. So any changes that are made, those can be done using the update feature. Right? You can see also the devices based on whether they are enabled or not, they are ready or not. So you have multiple tabs to filter devices out within this StealthWatch tab. So whenever there is a device which is not ready, you will also see why it is not ready, whether it's the code compatibility, whether it's the licensing. So you can just take your mouse over that particular red cross and it will show you exactly why it is giving you that message, right? So here is what the configuration is going to be pushed on each device. So basically this is the FNF configuration, which is going to be pushed globally, where it will create the flow record information, IPv4 protocol, the port, the source port, destination port. I mean, all this information will be mentioned, right? And the destination of your the flow controller or UDP director, whatever you select, what port, right? And this will be done globally, also the flow monitor. And it will also do it at the port level. If you see, it will create this IP flow monitor input and output option on the each switch port where the users are going to be connected, right? So all this information gets pushed by the DNS center, so you don't have to automate it anymore. Earlier, all of this was needed to be created as a template or as a script and pushed to all the devices manually. So that time consuming, error-prone thing is going away with this particular integration. So from a RBAC standpoint, I'm sure you guys already know about DNS Center's RBAC capabilities. So DNS Center now has role-based access control where you can have multiple users, and all those users can have different types of access levels, where you can say, okay, the user one should only be able to view certain things. They'll only be able to change certain things. So you can do that. But if you are creating that RBAC role, you need to provide these different, appropriate accesses, whether you want to let them write or whether you just want to have a read-only access, depending upon you. So you need to provide right type of access for them to manage the StealthWatch part of it. So for now, there are certain limitations. In non-fabric deployments, right now only wired traffic is supported. We are not able to do it on the wireless currently. So that's something they are working on already. So pre-checks, as I said, pre-checks are there, but they are just a spot check. They're just checking certain information on your devices, right? Basically the licenses, the advantage, the licenses, the configuration mismatch and all those things. So that's another thing. From a fabric standpoint, the fabric monitoring can happen. For the wireless on the fabric site, it says here it's monitoring through SSA, but it is not available for general public as of now. It is still in testing. So it should be out sometime later this year for wireless side of it. So currently you can say that it's still working for wired fabric and wired non-fabric deployments. For wireless, it is coming out pretty soon. Okay, so here are certain resources on different features of StealthWatch, ETA, and NAS. You can go ahead and read about those. You can see if there are any questions, you can always let us know, right? So I will be sharing this presentation. Okay, this brings us to the end of this presentation. Let me see if there are any questions. Okay, I don't see any questions. So are we good to proceed to the next slide, or if you guys have any questions, please feel free to unmute yourself and ask. Okay, no more questions. Then in that case, let me stop this one and open my last presentation for the day. So we are going to go through the last presentation now. It's not going to take more than 20 minutes. After that, we can take a lunch break, right? So let me quickly go through that one. And okay, so this is another integration that we have available now with Cisco DNA Center, the umbrella integration. It is again an initiative for making it easier for the network administrator to manage everything from a single place. And umbrella is also a very, very popular security tool. So Cisco wants to provide that option within DNA Center also, because we already have started doing it for SD-WAN side of it, and there's also available integrations available on the data center side of it. So on the DNA Center now, we also have the umbrella integration available. It is somewhat limited as of now. We will tell you what limitations are there, but yes, we will be kind of expanding it, and we'll be providing more and more features with upcoming releases. But for now, let me show you what all we can do with it, right? So we will be going through the challenges, the overview of umbrella very quick, and then how it works, different models, what the prerequisites are, how it works in a solution architecture type, and then flow diagram. And then we'll see quickly how to configure it. Okay. So challenges, again, I'm not going to go very, very deep into it again, because we have been discussing about the security challenges throughout the day. So security challenges, basically, obviously we know they are very, very unique these days. But one thing that I want to mention is whenever users are accessing internet, most of the organization are skeptical about what they are accessing, how they are accessing it, whether those sites are secure or not. And the best way to secure the traffic is to know what is the destination's reputation, right? What kind of URL they are accessing, whether they are accessing gambling site, whether they are accessing, unsecure sites where there could be malware infected traffic. So the requirement here is most organizations are very, very skeptical about specifically the usage of internet in their network. And that is why you see a lot of URL filtering happening. But think about the situations like hotels or even hospitals where people are provided guest access using those particular organizations' network, even the universities, right? So all those places where those particular organizations are providing guest access to the users to access internet, and then they need to also ensure that there are no network breaches, or the content that they are accessing is secure and they are not using anything that they shouldn't be using, right? So all of that can be done using DNS security. So we'll see how it happens, right? Because if you keep on filtering anything and everything at the firewall level, then it becomes very, very cumbersome. Anybody, again, who comes from firewall background or security background, you would know that doing it on the firewall or any other device which is not really purposely built for that particular feature, it puts so much extra, you know, load on that particular device. And because obviously filtering at anything at the application layer or even at the DNS layer, it takes more processing, right? You need to really look into the packet that particular deeply, right? So that's where this solution comes into the picture, which gives you a very, very flexible option to deploy DNS level security. And again, it's not a new feature. It's been there from quite some time. You can do umbrella with a traditional network without ever going for a DNAG or going for SD-WAN solution. We are just providing you additional feature set within these solutions also, so that you can automate all the deployment for all these different security features, right? So Umbrella comes with multiple deployment options. It is a cloud deliver solution. You can deliver it by just simply pointing your DNSs to the Umbrella DNS, or you could deliver it using the virtual appliances. So let's see, right, how that happens. So within the Umbrella, there are multiple services available now. For SD-WAN, if you see, we can do, within Umbrella, we have cloud delivered firewall, we have CASB solutions within it, we have threat intelligence with our ThreatGrid Cloud, we have a secure web gateway feature, which obviously is more like a term for the SD-WAN integrations. And DNS layer security is obviously the primary feature, and that is what we're using. Look, if you're looking at all these features, most of these are relevant when you're talking about the SD-WAN integration. But for DNS Center, we're talking about the DNS layer security as of now. So I just wanted to give you different capabilities of Cisco Umbrella as a service. So there are multiple services that you can use within Cisco Umbrella. But for DNS Center integration, we're using DNS layer security, right? So I will share this slide for sure, just to, if you want to go through different feature sets. And we have a dedicated Cisco Umbrella video on Cisco Live. You can just go search for it and you can find different information about it. And if you want to know more about SD-WAN integration with Cisco Umbrella, there is a SD-WAN module for a SD-WAN training where we talk about this. So you can also explore that. Okay, so why Cisco Umbrella is for DNS level security, right? Because as I said, the internet is something that is a very, very scary place for a lot of people. And from a access standpoint, there is so many unfiltered content, and there's so many unsecure content, unsecure websites that are malware infected, that are there just to simply get in a way to your network to make it vulnerable, to exploit vulnerability within your network. And internet is the best way to do it, right? So 90% of the malware use DNS attacks, right? So they basically send their traffic or their initial packets to infect your network using DNS. And one of the three malwares actually use DNS in attack, right? So there are different parameters, different studies that are focused around how the malwares or the threats are using DNSs to exploit more and more of your network. Because in most scenarios, people do filtering for unprotected sites or unencrypted traffic. They encrypt the traffic, but DNS traffic is going in unencrypted, and it is going to global open servers most of the times for internet, for guest user at least, and that is where you become more and more vulnerable to DNS based attacks. So Umbrella provides you that security. It automatically blocks the sites which have bad reputation, and it uses one of the biggest reputation engine for DNS is called the OpenDNS, or used to be called OpenDNS. So that particular one of the biggest engines or biggest database of threats or reputations of different DNSs is locked there. It uses that. It can also help you do granular control on the cloud, where you can say, okay, these are the types of sites that I want to be accessible within my network. These are the types of site I want to be blocked. These are the types of the site I want the guest users to access. So all those things you can do on the Umbrella Cloud, and those policies get pushed to all the users, right? So how that happens depends on the different deployment models, right? So just how a little bit more about Umbrella feature set. We already discussed about all these things, that it can help you with the malware attacks. It can help you proactively respond to threats. Obviously, it will help you control the type of traffic that you're sending to the internet, and control the type of content the people are accessing within your network, right? So all that is done by Umbrella as a service or as a solution. You have options to do the Umbrella inspection for your on-campus devices, your off-network devices, and even mobile devices. So we have agents that can integrate with AnyConnect as a client and can do Umbrella integration, even if you're not in your office network, even if you're not connected to your office network using AnyConnect, you can still use Umbrella plugin to monitor your network traffic and ensure your network is secure, or your users are using or accessing the right type of content, and they're not downloading any malwares while browsing the internet. Okay, so DNS layer security is deployed widely because it is simple. It is very, very effective. So there are multiple different vendors that provide you with that. There are multiple different types of options, cloud, on-prem. So it's already there, and it ensures that your traffic, even before it reaches the parameter, it ensures that whether it should be accessed or not, right? So the user sends a request saying, okay, I want to access this gaming site, and your policy says the user should not be accessing the gaming site or the shopping site during the work hours. So that request will be denied. The traffic would not even reach the gateway or the parameter, right? So basically, it is that effective and stops unnecessary traffic going out from your network. So here are the different models of deployment. You can do it based on the server. So as I said, it is very, very easy to deploy. You can just go ahead and go into your DNS server. Sorry about that. You can just go into the DNS server and point your DNS server to the Umbrella DNS. And that's it. Your network is secure using Umbrella from a DNS security perspective. But there is a limitation to it, that you would not be able to see who is the user, because everything is coming from your DNS server to the Umbrella cloud. So it only knows about your DNS server. So it does not know who's the user, when they were accessing it, what type of device they were using. So all that information is lost. The other option where you get more visibility, that option is to deploy the virtual appliances. You can deploy either one or two different appliances on-prem. Those appliances will talk to the Cisco Umbrella Cloud for threat level detection. But since those are the DNS servers in your network now, your endpoints are actually going to talk to them. So if the endpoints are talking to them, they know exactly who was sending that request. So now you have more data available. You can also integrate them with the AD. And once you do that, you have even the user information. So all that information is available if you do virtual appliances. But again, it is a bit cost intensive because obviously you need to provide the compute to create these appliances. You also need to manage them. So that is basically a little bit complex. But with DNA Center integration, we provide you even simpler way of doing it, right? So this was your manual process where you would either do a deployment using virtual appliance or the DNS server. DNS server, while it was not time consuming, it provided you limited visibility. Virtual appliances were a bit time consuming and cost intensive also, but there were other complexity like providing the compute, finding out, or integrating ADs and all those things. So those limitations were with the traditional way of doing it. But with DNA Center, we are automating a lot of it. And let me tell you what all is there. So it will help you easily deploy it and conveniently push the policies directly to the devices and even create granular policies based on different types of SID. So let's see how it happens. So the primary thing is the prerequisites. You need to have the Advantage licenses, umbrella account, obviously. The policies and domains on the cloud for now are required to be created manually. We will be automating that. If you see right here, the policies from DNA Center, it is a roadmap item for now. We will be, Cisco is already working on it, so we will be automating that part for you later on. As of now, so I was saying in the beginning, as you remember, that there are certain limitations to it. So the limitation is that as of now, we can only do it for a Cisco 9800 wireless controller for non-fabric SSIDs. It can be done for both enterprise or guest SSID for both local or Flex Connect mode. That's all supported, but we cannot do it for fabric SSIDs as of now. It is only for non-fabric SSIDs, right? And the network device, that's another limitation or another prerequisite. Then the network devices, when I say network device, that means the wireless LAN controller, that needs to be discovered and managed by DNAC. And the SSIDs that were created, that were also created by DNAC, right? And if you have a EWLC on a 9300 or 9400, that EWLC will also have to have direct internet access so that it can talk to the umbrella cloud. So you need to allow your EWLC to have internet access to umbrella. Then there shouldn't be any proxies there. So that's the prerequisite. So basically right now we were focusing when we started. So, you might ask why just the wireless, because guest SSIDs or guest networks are normally the wireless networks that we create. And as of now, Cisco was focusing on the guest use case where, as I was saying, once a guest onboards into your network, they are using your network to access the content, and what they are accessing somehow becomes the responsibility of your network, right? And at the same time, you also want to ensure that they are secure while they are browsing internet through your network. So both of those things were primary focus to ensure that the network is not being misused, and at the same time to ensure that the people who are using the network as a guest are also secure and are protected from different attacks that are out there in the network, internet. Okay, so workflow this is how it looks like. So once you have created your umbrella account, you created your policies on the umbrella account, you integrate your DNA Center with umbrella. That process is a bit manual. So if you remember from a StealthWatch perspective, we just provided the IP address and the username password, and then it was able to download the cert and able to create, integrate StealthWatch easily. But here it's a bit manual, so I'll show you how it happens. So once you have integrated, you select the SSIDs because you'll be able to see the SSIDs on Umbrella now. Once you see the SSIDs, you can go ahead and choose what profiles you want to use for which SSID. That's something that's out there now. A DNS script is something which we'll talk about a bit later. So this is the workflow. Basically, your DNS center will go ahead and configure the umbrella settings to your WLC. In fact, even before that happens, the DNS center needs to register with umbrella. That information will be exchanged using the API tokens and the keys. That information is still something that we will provide manually in the DNS center. So I'll show you that where to do that and how you get that information, right? So once that is done, DNS center pushes the DNS information to WLC. Now WLC is going to have internet access and it is going to go register itself with umbrella, and it is going to also share the SSIDs that are created here. So that information is going to be on umbrella, and once you have that information, you can run the workflow and choose different SSIDs for different policy that you have created on the umbrella, right? So let's see. And anything that is approved or denied, obviously that information is sent directly from umbrella to the WLC. And so that whenever the request comes to WLC from a user, WLC will know whether to allow it or not, right? So it does not even have to send it to the border node, or not in the border node, basically wherever your gateway is. It does not even have to send it to the gateway. Okay. So here is the flow. So basically you create your policies, you generate your API key, secret and token from the umbrella cloud. Once you do that, you go ahead and provide that within the DNS center settings, and DNS center will register itself with the umbrella and get all the policies and whatever domain that you created here. And that policy will be provisioned on the WLC. WLC will then register itself with the umbrella and get that information, get the information about the policy or whatever is configured in here. It will be able to download all the different parameters that you created, allowed list, backlist, whitelist, right? And that whenever there is a client that is sending some traffic to the internet with the DNS query, WLC will look at it. It will check the query using the DNS EDNS, and depending upon that, it will respond whether to allow or deny it, right? So this is how the overall flow looks like. So here's the workflow. So this is what I was talking about, that you need to generate, or I mean, it's already there. You just need to go and collect this information from Umbrella Cloud. So you need to get this information for the API keys, because that's something that is required for integration. And you also need to create your policies, define which policies for which SSID. And you also need to create your domain, which domain you are doing this particular policy for. Cisco Umbrella update is something that you need to download if you have not downloaded it in the DNS Center, but in new versions it's already there. So you need to then go ahead and go to the settings in the Umbrella integration in external services and provide the registration secret, which you copied from Umbrella Cloud. Management API key is also copied from there. Secret is also copied from the cloud, and then legacy device registration token is also copied from cloud. It's right here. So it's right here. All that information is right here, right? So you can just copy and paste it to the DNS Center. So right now this part is manual. Cisco is trying to automate this part also. So soon you'll just have to kind of create a username and password for DNS Center like you did for a Stealthwatch, and then it would be integrated. Okay. Another thing, the dashlight, as we talking about the Stealthwatch earlier. Here also, umbrella dashlet is not present by default. You need to go ahead and add it. Just go into the System 360 dashboard settings and add umbrella dashlet. And once you do that, you will be able to see your org ID and also the availability of umbrella, whether it's available or reachable or not. Then again, you go into the provision and umbrella workflow. Once you launch the umbrella workflow, you will again see the sites. Within the sites, you will see the devices that are ready for the deployment. You select the devices. That would be WLC as of now. And once you do that, you will see the SSIDs that are there. And then you can select the SSID and select the policy. So right now you only see default policy and it says current release supports default policy. That is because it was in this screenshot is from a 2.1 version. In 2.1, 2.4 and above, you will be able to select the policies for each SSID basis. Okay, so you can create different type of policy for your guest SSID. For your, let's say you for guest SSID, let's say you want to allow them to access maybe Google, Facebook, or whatever you want to allow them. And then for maybe for enterprise SSIDs, you want to allow them other different accesses. So you can create policies based on the different different SSIDs, right? And then you define your domain. The DNS script. So this is something that you need to enable if you want to secure your DNS traffic. As I said, DNS traffic is unencrypted, it's UDP traffic. But if you want to encrypt it, you need to enable this, and then the traffic goes encrypted. But if you are using DNS script, make sure that your parameter firewalls or any proxies that you have are not doing any DNS level inspection. If they are doing it, then the DNS script traffic does not get passed through, obviously, and it gets dropped. So make sure that is not happening just in case you are using DNS script option. Okay, so you can go ahead and this is a summary. Once you are sure everything looks good, then you can go ahead and deploy it. Once it is deployed, it will show you the success message and it is all ready. And if there is any update, like say you changed anything on the umbrella cloud and you want to update that, you can just select update option and go ahead and make those changes. And that is it. So this is what the configuration would look like. So these are all the things that will be pushed to your wireless LAN controller. Again, as of now, it is only for the wireless LAN controller, which are iOS XE based wireless LAN controllers, and only doing enterprise and guest SSIDs, which are non-fabric. Okay. RBAC permissions, again, this is a specific feature where you can either enable different types of roles, deny, read, write. So you need to provide appropriate access levels to the user so that they can manage these parts. So here are certain references for the DNS Center and Umbrella integration. We will share this. Certain FAQs, let me quickly go through them. So Advantage licenses are required for Umbrella, but currently, in the current release, we do not have any enforcement, but again, the enforcements are happening going forward. So make sure that you have the correct license level. Hardware versions is only 9800 as of now. We are going to add more devices. From a brownfield perspective, if you say that, okay, I want to do Umbrella integration, but I have already created my SSIDs in WLC, how can I do that? So there is a way. It's a bit. So what happens in the new code in 133X and above, DNS Center is able to learn the SSIDs from brownfield WLCs. So what you can do is you will discover your WLC through DNS Center, and if you discover it, any SSID that you created manually earlier, will be learned by DNA Center, and you will be able to see that in your network design and wireless profiles. You'll be able to see those. So now all you need to do is go into the network settings, select your umbrella for the WLC, and when you'll have to reprovision your device once. Your WLC will be reprovisioned once. Once you do that, you will be able to use umbrella for your existing existing SSIDs. Just be a little bit of just a little bit of heads up is whenever you provision WLC, it is basically pushing this configuration again, right? So it shouldn't really have any major impacts in your network, but make sure that you're aware of and you take into account that your configuration of WLC is being repushed to the WLC basically with the umbrella settings. Everything else remains the same, but the umbrella settings will be pushed again. So that's the only way of making it work, because now when you repush it, the checkbox of DNA Center to check, DNA Center does a check basically saying, okay, whether this WLC was provisioned by DNAC or not. So when you do this reprovision, basically DNA Center pushes that brownfield SSID that it learned from WLC again, and now it looks like a SSID that was configured by DNA Center. So that's how you can do it for the brownfield. Otherwise, if you want to have a simple answer, a short answer, then yes, you cannot do it in the brownfield. You need to do it. You need to create SSID using DNA Center only, and then it works for it by default. Can this integration be deployed as an overlay for existing umbrella deployment? Yes, if you already have an umbrella deployment and you still want to do it as an overlay, you can still do it, so that you do not have to manually configure everything on your endpoints. Is this integration available in DNAC Cloud? Not really. It's not available today. And then obviously DNAC Cloud is also, we have a different roadmap for that. So when that is available, we will share that information with you. Okay. That brings us to the end of the presentation and end of the day one presentation. Next part of today will be the lab, which we would be doing after the lunch. So currently, let me see. So it's 1 p.m. now, right? So Ray, is 1 hour enough for the lunch break? So what we can do is we can take a 1 hour lunch break from 1 to 2. Okay, thank you, Ray. So 2 p.m. we will come back, and 2 p.m. we will assign you your pods. We will tell you how to access it, and after that you will be good to go with the lab. We will share the day one lab guide. We already had shared it in the Teams, but I'll share it again. Sandhan will share the box link, and after that you should be able to do the day one lab. In case you have any questions, we'll keep the WebEx going. You also have WebEx Teams. Feel free to answer any questions there, and we should be good from there. So please enjoy your lunch and come back at 2 your local time, and then we will go from there, right? So rest of the day is lab. We'll start with the presentations tomorrow again. So I'll make Sandhan presenter because he'll be sharing with you how to use the lab and everything else. But for now, you guys can go for lunch, and let's come back at 2. Thank you, guys.
因为我还有一个会。其实应该白涛等一下我帮你们分这个这实验的完景，然后就我们因为今天我们应该有20人啊，有20人，我们真的是2个人应该2至3个人一台机甲吧，是因为我们的机甲其实不够，只有九台，只有9个 port。所以呢，不好意思，那就等一下白套分的时候，那就麻烦可能白套说一声，因为你等一下你们也是在 Q&A 里边可以跟他说吧。
一会儿我会基于签到来分类吧。那个我优先会让一家公司有2个人的共享一个类吧，然后签到的肯定都有。那可能现在目前签到的肯定是不足2个人 share 一个的，有些人可能是1个人独享。那如果有想继续进行实验的，赶紧签到啊，因为我只有签到信息才分得了类吧。
If you have because after afternoon will be the lab sessions, and if you do not sign in or registrations, Vital cannot please because today lab session is not enough. Maybe 2 or 3 people in same company will be using the one lab. So just so what can if you do not need the lab, is let Vital know that.
Good morning, good afternoon, everyone. I'm Sunan Mohapatra. I am basically a colleague of Narendra and Abhishek who delivered this session. And so you'll hear more from me tomorrow about all the topics. But yeah, since you guys went for lunch, do let me know once you're back. I'll just try to show you how to log in to our SWOT lab, to the SDA labs that we have, so that it would ease the process through it. So I'll just wait for a couple of minutes more so that everyone is back from their lunch and we can take it forward. Okay. I hope everyone is back. I will start the recording. Okay. Right. So guys, before we went on break, I pinged a box link. I believe everyone do have access to that. In the WebEx chat window. So if you click on that, it should take you to this particular box folder. What I have done is I've placed the lab guide for day 1, day 2, and day 3. Okay. So of course, since we'll be starting the day today itself, so we'll click on, if you want, you can go ahead and download that, or if you want to access it from the box folder itself, you can do that as well. Okay. But first of all, I'll let you know how to actually log in to your respective ports. So I have that document, the PDF file already open in my computer. This is how it looks like. Let us just talk a brief about the topology. So if I scroll down, this shows up the logical topology that we have, okay, wherein we have the shared services, the DNS center, your DHCP scope server, your DNS, your SD-WAN controllers, all are behind this data center switch, okay. Then we have a ASA firewall, which is connecting to your guest fabric or guest border, and which is also connecting to your internet, okay. And if you look closely below that, we have a WAN router over here and a campus, a border control plane over here, okay. This site, what we call as a two-box solution, or if I say this is a two-box solution. One is a part of your SD-WAN, one is a part of your SD access, okay, the border and the control plane. But on the left-hand side, for the branch, I have only one box solution. When I say one box solution, your SD-WAN router, your C edge, and your border and your control plane node is on the same box. Okay, that's what we call as one box solution. Okay. Rest all of the things are absolutely the way it is. This branch location is connecting to your campus WAN router via SD-WAN transit, which is the new transit that came into picture in 2.1. Prior to that, it was only IP transit and SD access transit. In this topology that we have showcased in the lab, we are primarily focused on IP transit and SD-WAN transit. Okay. Now let's just scroll down a little bit more. Okay. This slide talks about all the interfaces that are connecting to the respective devices. So I'll leave it as it is. Just to quick rundown, we are running ISIS in here from the border to your CPS edge, CPS FE, and your L2 border, or the routing protocol that is running with ISIS from the border to your to your WAN router. It's running BGP. It's the eBGP that we're running. Everywhere else, it's all eBGP. Okay, just to give you a heads up. We have just tried to mention the IP schemas that we have used. This is primarily for your IPv4 addresses. Okay. This is how it's supposed to be. Similarly, we have done it for IPv6 as well. This is we're trying to showcase we can use IPv6 in our network without any challenges, even for your fabric. Okay. For your guest site, this is how it looks like. We have a border control plane node, which is common for all the sites for the guest traffic. There is a feature called multi-site remote border, which we have a session, which we'll talk about tomorrow once I do the session. Just to give you an idea, your multi-site remote border allows you to have the same subnet across two different sites or multiple sites. Prior to this, we did not have an option to stretch one subnet from one site to another site. But by using multi-site remote border, we can do that. Most of the time, it's being used for your guest traffic. So that's how we have placed it. Okay. We have the campus border, the CPS WAN connecting to your ASA Fusion. Your ASA Fusion is basically your firewall, and the firewall is connecting to your guest traffic or the guest border. Okay. On the branch side, just a little granular representation. Your branch one side is connected to your service provider switch, which has your MPLS and internet connectivity, okay, for your SD-WAN topology or fabric to work. All right. This SP switch, the service provider switch, which we saw before, is the same way. The branch is connecting on that particular site, on that particular switch, and similarly, your WAN is also connecting to that particular switch to get your internet and your MPLS links forwarded to each other. Okay. In your cloud, we have the vBond, the vManage, and the vSmart. The concept of your SD-WAN, the controllers, all those controllers are present in the cloud, and that's how we connect to them. Okay. And just a quick representation about what are the IP addresses that we have assigned for your vBond, your vManage, your DNS center, your ICE and the wireless controller and the DHCP DNS servers. Yeah. Probably I clicked on the okay. Now, just a quick showcase about how to connect to your labs. Okay. So if you scroll down, you have something mentioned over here, access info for AnyConnect VPN account. So what you need to do, you need to AnyConnect on this IP address. So I'm sure all of you have Cisco AnyConnect. So what you need to do is just copy this IP address and click on connect. Okay. Right. Okay. So once you click on AnyConnect, it will ask you for a username and password. So suppose if I'm doing it for pod 1, okay? So your username would be user-pod-01, okay? For 02, the pod 2, it would be pod 02. And similarly, it goes on to pod 10, okay? Pod 10 at the last. We have the same VPN password for everyone. You just have to copy that password and paste it over here. Once you do that, click on accept. And you should be able to connect. One important thing that you should be aware when you connect to AnyConnect, I'll just open again. Go to settings in this here, in this button. If you click on this button, click on the preferences over here and uncheck this box, okay? It should be unchecked. This particular box, okay? If you leave it like this, it will be a challenge. So leave it unchecked and just apply. Once you do that, so as you can see, we have assigned respective jump hosts for all the respective pods. So whosoever is connecting to pod 1, he or she would be able to join on this, would be logging to this particular jump host, pod 201. Okay. Now, since I'm AnyConnect to pod 1, so what I'll do is I'll keep open RDP session, remote desktop session. I'll type in the IP address of the RDP session of 100.127.12.201. I'll click on connect. Once I click on connect, it asks for a username and password. Ensure the username is admin. If you did not see admin over here, just click on more choices, use a different account, and type in admin. Okay? And the password is here, DNAC123, the way it is. And click on OK. Once you click on OK, it will give you a certificate error or a warning. Okay? Don't worry about it, just simply click on yes, and it should take you to your respective jump host like this. Okay? On that jump host, if you click on any browser, suppose Google Chrome or whatever, if you choose Google Chrome or Firefox, whatever it is, we have the hyperlinks already mentioned over here. Like if you want to access DNS Center, click on this, click on Advanced. Okay. You will have this page where it asks for username and password. The login for your DNS Center, it's all mentioned, the user credentials. You will have this IP addresses mentioned over here. Okay. You have the username and passwords mentioned where it shows what, if I want to log into this, what is the username and what's the password. Okay. Similarly, we have mentioned for all of those devices. For example, for DNS Center, I'll just type in admin and the password is DNAC123 exclamation. And once you do that, it should log me to the DNS Center and we should be able to go forward. Okay. Now, once we do that, this is basically your DNS Center. You just have to follow the guide. It's a simple process and it will guide you through. Similarly, your vManage is here. Okay. We have the hyperlinks. If you're not comfortable with hyperlinks, you can type the IP addresses that is mentioned in here. Okay. Every IP addresses is mentioned over here. So nothing to worry if you miss down anything. Okay. And along with that, we have mentioned the IP schemas that we are using in our network. These are the only IP schemas that we're using. And please stick to it because our lab has been designed in such a way that only this IP pools that we mentioned, if you use those IP pools, IP subnets, then it will work correctly. Otherwise, there might be some differentiation. Okay, there might be some deviations. Just follow the guide and it should walk you through. One important call out, I definitely want to call this out. Recently, we have seen the partners are not following the instruction correctly. And this is basically for lab day 2, not for day 1, it's on day 2. There is a lab activity where we have to do a reset of a switch. Okay. For that, we have to use this command. Okay. Factory reset config. It is a strict instruction, or I would request rather, please use this command as it is. Do not use any other command apart from this. If you use any other command, for example, factory reset all, it will wipe out all the configuration from the switch, even the iOS image. And due to the COVID situation, we do not have anyone on site to get the switch up and running for us. Okay. If you do this, if you stick to this, well and good. If you do anything else, then you would probably have to deal with less lab activity because there are a lot of activities that happen on that particular switch later on as the lab progresses. Okay. So ensure you use this command only. Do not deviate anything from here. All right. So I'm sure you must have access to this box folder. Try to any connect the way I did. If you have any issues, you can reach out over the chat in here. or else whosoever has access to the Cisco Teams, you do have the team, right, where everyone is joined. So you can use this and let us know if you have any challenges, okay? I'll happy to jump on. I haven't created separate WebEx link for different partners because I believe since we had multiple partners, if you have any WebEx links of your own, then please feel free to use that particular WebEx link. That's absolutely fine. If not, then let us know. We can create WebEx links for you, for which you can share between your colleagues and you can work on the pod. Okay. Meanwhile, I'll share the pod details about who owns which pod, so that you guys can be working on that particular pod only. Do not use anyone else pod. That will just create the mess which we do not want. So let's use the pod that you will be assigned, and I'll share that details shortly with you. Okay. If you have any questions, please feel free to reach out to me, Narendra, over the WebEx chat or the WebEx team. We are absolutely looking forward to it. Okay. Ray and Bhato, I guess Narendra pinged you on the WebEx team. Can you please share those details over the teams so that we can get this thing rolling and we can share the lab details again? I guess Ray dropped down. Bhato, can you hear me? Bhato, you're probably speaking on mute. If you can hear me. Guys, no problem. Okay. All right, guys. I will. So give me some time. I will share the lab details for the teams, and we can get this lab rolling. Okay. Let me just pause the screen share. Guys, meanwhile, please access the box folder. This web, I'll paste that web box link again. Please try to access that. If you have any challenge, let me know. Otherwise, just give me a thumbs up, or you can just unmute yourself and let me know if you're able to access that box folder or not. Okay. So what I'll do is I have that box information. I will upload that on the box folder as well, so that whosoever access the box can download the information. Okay, which pod has been assigned to whom? Please access the box folder, and you should have that information as well. Guys, were you able to access the WebEx chat, the box folder? Can you give me a heads up? Yes, no, maybe. Raymond, I saw your question now. If you open that box folder, uh, you will see that, okay? You will have your name again next to your next to the partner list, and you should be able to access it. The name of that file would be Uh, Raymond, did you access the box folder? It's in there. If you see my screen, right? This is how your box folder would look like. Okay. Click on this Excel sheet, and it should show you your respective teams, which all partners you have been assigned. Okay. Raymond, you are going to be using pod 5, just for example. Okay. Use pod 5. So we have used those pods, given 2 people to work on 1 pod. So use it like this, and let me know if you have any challenge. So we try to give them as per partners. So yeah, please feel free to use it and let me know if you have any challenge. Okay? You're welcome, Raymond. And you must have received an email from Balkav as well, where he has sent the email to everyone. So feel free to use it. I hope everyone has WebEx team for communication. In case I see a lot of people there, I hope everyone is using WebEx team, because we are actively monitoring here. In case if there is any challenge, feel free to let me know. I can come back on the WebEx chat and respond to it. Though most of us monitor this Teams rather the WebEx chat. We use the Cisco WebEx Teams more often to monitor the chats. But yeah, if you're not able to download or use it, let me know. So we can stick to WebEx chat, no problem. All right, guys. On that note, I'll let you guys leave. You can take your time to log into the pods. Try to log in. If you have any problem with the pods, log in. Reach out to me. Otherwise, any questions, any query regarding the lab, any content, reach out to us and we'll definitely answer you. Okay. Have a happy learning. Cheers. Bye bye.